Okay, and now clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got winners, give them a round of applause!
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the combat system, the area control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay, and now clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got winners, give them a round of applause!
with some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
The combat system, the area control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay, and now clap your hands.
Okay, how's everyone? Is that all? Louder! Okay, that's good. Okay, so today we are in a Beamery that they're sponsoring us. We have a number of sponsors this year, and you can see there, but I will show you in a second. Normally we do meetups, but we don't do it during the conferences. But last year when we were doing the conference in Athens, I came up with this idea of like warm-up events before the conference. And what's doing that? Okay, I'm not going to speak too close to the microphone. And I thought of before someone comes to town to come and meet the local community. So we started doing these warm-up events. And here we are. So we are at Beamery today. So CityJS London, it's a community event for developers by developers. And I have to say I have a special guest today, Dylan. Dylan, raise up.
Where are you, Dylan?
He also runs Halfstack. It's in November, right?
Yes.
Yes, so we are like brother, but like father, brother. Yeah, he helped me to start CityJS, so I have a very special bonding. So that's how we started CityJS a long time ago, before the pandemic, and it went to a lot of other cities around the world. And today we have like an amazing lineup. Some people coming from all over the world. We also have we're doing the Microfrontends Summit, but we have someone that created the Module Federation here, so Zach. So you can talk to him about the Module Federation after. I think these guys are working on something, they told me, but they will tell us during the conference. I'm waiting for that. Yes, so we have 7 speakers. And yeah, it's gonna be fun. So I want to thank all the sponsors that sponsors our event. We keep the prices low compared to other conferences. AWS, Storyblok, Bonnet, Metis, Twilio, Foolproof, Cloudinary, GWI, Contentful, Paylor, the Paylor guys here, you can talk to them. Beamery, Human First, Sneak, Hasura, Sticker Mule, and Platformatic. And that's me for now. And you have Simon Coates, that he's the head of development for Beamery. Thank you.
Thanks, Rolla. So this is embarrassing with a big, huge picture of me on the screen, so I'll move to the next slide. First of all, before I give me information about Beamery, I want to thank Aris and the whole team CityJS for helping us put this event on today. This is an amazing event. I've been involved since the first conference and day one. Huge round of applause for Aris and the whole team, because this is an amazing event. So many things are happening this week because of Aris. And secondly, I need to thank my Beamery team as well. So Verity, again, this happens because of Verity. Charlie, Matt, Elliot, Fred, Manu on the drinks, who I'm not mentioning, Becca, the whole team here at Beamery, thank you for helping us put this on today. So, what is Beamery? So Beamery has a talent lifecycle management platform that helps us bring together candidate data, employee data, and alumni data. We're an AI-powered platform. We are using Node.js and React throughout the stack. We also, this week, announced a really exciting first. GPT is huge at the moment, with generative AI being a huge topic across the industry at the moment. We've announced this week Talent GPT, the world's first generative AI for HR technology, incorporating our own proprietary AI, of which our own Edge AI team has won an award recently, as well as OpenAI, LLMs, etc., etc. We're going to be launching amazing new products with this. And if you think that's interesting, and if the slides work, we also have some open roles, one of the companies we're still hiring. The most interesting one for this crowd might be the senior front engineer that's focused in London. We're also hiring product ops, product designers, engineering managers, and data engineers. So if you're interested in any of that things, what we're doing, or the roles, come and have a chat to me, chat to Manu behind the bar, Elliot at the front stall as well. And if you would like to know more about what we do, I will be introducing Sasha, our senior front engineer, to give the first talk. Welcome, Sasha.
Hi everyone. First of all, I would like to say thank you for CTGS and Beamery for having me today. My name is Alexander Hirich. I'm a senior software engineer at Beamery, and I focus on full-stack web development. Over the last 4 years, I've been implementing and leading micro-frontend approach in many organizations. That's why I'm going to talk about this topic, modularizing your front-end from simple monolith to micro-frontends. So let's get started. First of all, let's answer the question, what is micro-frontend? So the same like with backend microservices, you can split your front application by smaller independent parts. And those parts can be owned by different teams, built and deployed independently.
Sash, is your slides or look on the screen?
All right, sorry. I'm sorry, I started sharing my screen using this. All right.
They're all stitched.
Okay.
Yes, unless you change them.
All right. So yeah, like I said, I already explained what is micro-frontends. And let's talk about benefits of micro-frontend approach. So first of all, independent development, where team is more focused on the subject area. And another one is independent deployment. So teams will be more autonomous. They can deploy their features whatever they want. They don't depend on other teams. As well as shorter delivery cycle, incremental upgrades, faster builds, faster tests. It's actually reduced complexity when you work just in one micro-frontend instead of the whole monolith. Also, with such approach, you can isolate errors and have more granular monitoring and alerting. Such a fantastic benefit, isn't it? One thing that I would like to pay your attention that microservices and micro-frontends, I mean the backend microservices and front-end micro-frontends, they are not completely the same. For sure, in development, they kind of similar. Different repositories or packages inside the mono repository. A CI/CD process, quite similar, right? And it can be owned by different teams as well. But at runtime, they're not similar at all because everything running in the web browser. So that's why we have general event loop, shared document object model with events, navigation. So I guess we need to accept that we shouldn't isolate our micro-frontends too much, as well like decompose our micro-frontends too much, and still achieve those benefits. But sometimes people try to go further, try to have a lot of abstraction under it, and it leads to the many risks by architecting micro-frontends. So let's take a look on a couple of them. So, for example, the first risk and problem is poor code sharing methods. When we have eventually build bad web and build performance, sometimes people also divide our micro-frontends too finely. What does it mean? For example, you can have kind of well-sized micro-frontends and like split by domains, by major features, but sometimes you can create like 10, 50 micro-frontends, then eventually once you have to deploy something, you will spend a lot of time to kind of deploy many micro-frontends instead of the couple. So it's the way how you should split it, depends on your organization needs, depends on your product. As well as overcomplicated communication between micro-frontends. So sometimes people are trying to create some event bus, as well like some custom events, which will lead to the big cognitive load instead of just using React contact bus, for instance. Also, usually it can lead to the kind of problems with global libraries. For example, when you're trying to implement this approach, you'll have a problem with the web performance by loading the same libraries each time at runtime. And the final risk is when you're trying to provide kind of possibility to develop your front-end project using the different framework and libraries, which is actually high risk because you have to find developers that know Angular, React, Vue.js, and again, bad with web performance because it will be a couple libraries. At runtime, they do exactly the same. But yeah, it's actually challenging to implement such approach. That's why in most cases you don't need microfrontends. But what you can start with is a modular monolith in the mono repository. So basically you can split your application by modules, and each team can own specific module. And it's actually bring your independent development, which is nice. Also, good developer experience inside the mono repository, as well as low-level complexity. It will be still simple React application. You can also create custom shared libraries inside the mono repository and keep your NPM dependencies up to date. For sure, it will be some issues because it's still monolith. Your builds may become slower and CI become slower and no independent deployment. But maybe in most cases, you don't need it at all, right? Maybe it will be fine. So another thing, when you start working in the mono repository, it's really critical to use the right tool of generating your mono repository, of build your mono repository, and so on. So one of the best options, I think, is NX. All right. I actually have to share my screen. 1 second to show you quick demo. One second. All right. So here we go. So as you can see on my screen, I have NX mono repository. Actually, I generated it just in less than 1 minute. I use an apps preset, and it automatically generates me predefined TypeScript config, JS config, Prettier, and so on. But also, I use an NX React plugin to generate my application. I call it shell, as well as domains, dashboard, and order. So if you open the shell application, I just using the material UI to render simple application, and also actually import few modules like dashboard and order. Yeah. So and also as you can see on the screen, I import dashboard and order model from my shared libraries. As you can see, there is domains and dashboard. It's all generated by NX. Let's try to run it. All right. So I'm using NX plugin, VS Code plugin. I can just click simple command to store my application. All right, so here you see on the screen that I have a simple React application with dashboard page and orders page. And dashboard page as well use some model from the orders, I would say, shared model, like a recent order widget. Everything was quite good, and it's just a simple React application. And that I was talking about independent development. As you can see, I have a separate directory, separate project in one repository. Yeah, and it's exactly what we need, I mean, the independent development. Let me talk a bit more about NX. Why I said it's important to have a good tool when you bootstrap your mono repository. So using the NX, I can easily generate new application or new library. Using NX, I can, for example, generate easily, for example, one second. I don't know, let's say another library. By specifying the name and params, and NX will generate everything together with JS for unit tests and so on. As well, using the NX, you can run command like NX affected, and it will run only changed application over the main branch. Let's try to do it. I also going to use the so as you can see, NX, okay, like we changed something over the main branch, and it will rebuild the whole shell application, which is a really nice experience because it's easy to build CI pipeline. An interesting comments in NX graph, where you can see all relations within the project. As you can see, right now, connected between ourselves because we have this model monolith. So that means if you change something in the order directory or dashboard model, it will rebuild the whole shell application. And in most cases, it's okay. I mean, but once you discover that actually you need more, you need such an independent deployment, independent builds, which will speed up your CI pipeline, you can improve it. So you can actually improve this application by editing the tool, which will enable you independent deployment and build. So one of the best options, Model Federation plugin, it's a feature in Webpack 5, which is allow you to download modules at runtime from the different Webpack project, which is hosted on different domain host. It can be CDN, it can be some Nginx server which serves static. Let's talk a bit more about it. So actually, all right. So actually, in Model Federation, each your project, each your micro application that you build is called container. Container can expose modules and actually consume some modules. Can be remote or host, right? And from this point, once you add Model Federation, you can build your project independently. But at runtime, as you can see, it will load your modules inside the same application, which is exactly what we need. Let's talk a bit more about it. So another nice feature in Model Federation is shared scope and shared library. What does it mean? Once you, for example, have some micro application, it has some dependencies, for example, React. Instead of loading React each time, it will go to the shared scope, check if it's already in shared scope. If no, it will load it and put in shared scope and load React only once. So which lead to the great web performance. And it's really important that technology that you choose should has a great community. For example, Model Federation, many companies choose Model Federation such as Netflix, Amazon, and so on. Additional benefits of Model Federation that it shouldn't be only Webpack bundlers. So there is new package called Native Federation where you can, which you use, and it will become kind of bundler agnostic. So that means you can use federated approach in the ES build, RSPAC, and so on. And also Model Federation supports server-side rendering, which is really important. And there is specific plugin for Next.js. And this is the way that you can choose to improve your NX model repository and enable independent deployment and build. There is example of the React application. As you can see, the same application, we have main shell application, which handle layout logic, routing. We have order, which showing the orders page and exposed recent order widget. We have dashboard, which is just render dashboard page, and also use recent order widget. Each of the micro application owned by different teams. They build independently, and all modules loaded at runtime. And also, as you can see, there is dependencies. It's a shared scope. That means that all our applications use the same shared scope to load libraries only once at runtime. And let me show you final demo of federated React application. So, all right, there is another NX model repository, and I'm using the same preset, apps preset. So what I did, I generated a dashboard order and shell application using the NX React plugin by specifying flag if it's a host or remote. So basically, host is a shell application, which is our entry point main application. The same, absolutely the same code that I showed recently. It's just rendering the material UI. Using the material UI, it's rendering the base layout and handling the routing logic. All right. And the same code actually in the orders and dashboard. But the only one difference is that each of my project has model federation config, where I specify name of my project and what kind of modules I expose at runtime. So for example, order expose order service, which is the orders page, and recent order widget, which actually dashboard consume. So it's consume order as remotes and expose actually dashboard page as well. All right. All right, so, and let's try to run it. It's a live demo, we'll see. So because you can see, once I added model federation, I can actually run and build our project independently. It takes some time. We have to wait a little bit. Let's wait a little bit more. Looks like my laptop is pretty slow. Oh, nice. Oh, nice. So, as you can see, absolutely the same application. UI looks absolutely the same, and it's still single React application. But if you open the network tab and refresh the page and see all your requests, let's say JavaScript request, you see that main bundle loaded from the localhost 4200. It's our shell application. Then it see that it needs some libraries such as React, Material, and it will load, lazy load those libraries. Also, it will preload remote entries for other microfrontends and load actually microfrontends and load actually another, let me find it, another bundle from the another port, which is 4101, which is dashboard one application, and render it. So as you can see, it's the same. It acts like a monolith at runtime, but we host our microfrontends independently on the different ports. When I click on the orders page, it just loaded only one dependency, which is not yet in the shell scope, and load only one component and render orders. And once I go back to dashboard, you see everything already in cache, which is fantastic. And one more thing that I would like to do is run a NX graph command. One second. And right now, as you can see, each of my microfrontend is pretty independent, and I can run build independently, I can run test independently in the NX model repository, which is fantastic. So we have all benefits in model repository with NX, plus we have real microfrontends with model federation. And actually that's it. Thank you. All right, guys. I don't know, like, should it be the next speaker, or if you have any other questions, any questions you can ask?
Any questions?
All right.
No questions? Oh, many questions. Okay. You have the microphone.
Yeah, first of all, thank you very much. It was really, really great and insightful. But, you know, some alarm bell went in my head as you presented. Webpack, with all its might, is one of the oldest ladies around. And it's probably as good as the next tool that will come. There's already probably TurboPack that is kind of like running behind it, etc. The question is specifically, like, how would you compare the model federation feature of Webpack, and what does it fix that like dynamic inputs do not fix? Kind of like try to put it in a sort of like Next.js type of application where you already got like the pages, and you already got Next.js kind of like building like the different packages, like doing a lot of the heavy load that Webpack would normally do. So what does it solve that dynamic inputs wouldn't?
So we can get two answers. So one answer can be from Sasha, but the next answer will be from the guy who built Module Federation.
All right. All right. I will provide the quick answer. So this modification plugin is just override the default import behavior in Webpack, and then it's kind of enabled you to load another modules at runtime, right? So we can build them independently and then load those modules from another Webpack assembly from the CDN, from any host, right? And compared to Next.js, it's actually monolith, so you build it, right? And then you cannot build, I would say, it's actually monolith. You build the whole application, and you cannot do the same. You cannot, I would say, import some smaller parts of application from the different CDN buckets and so on. Yeah, so it's my small answer, but I guess creator of Model Federation will answer much better.
Okay, let's see.
All right, so dynamic importing inside of a monorepo versus federated imports. Similar concept, load chunks from somewhere. Main issue that I run into usually is, let's say, I use Next.js myself with federation. So the big challenge I run into is I have over 60 independent teams. So with that level of velocity and deployment, it becomes really tricky to say, update meganav. So either from a risk profiling perspective, I need to split up these applications. My financial part is separate from, say, my main commerce part. So if I want to update the navigation, that's like a 2-week process to roll it out through, say, 10 independent instances of Next. I can't keep it in a monorepo because of risk and some other things like that, so I need this distribution layer. What it ends up getting toward is some of our teams don't even know how to do the NPM package deployments because they've only worked with federation. They press merge and it shows up across the company in 15, 20 seconds. So it gives you a lot more scalability and flexibility beyond just like a single file system. But in general, it is dynamic imports between bundles. So similar kind of concept, but you don't have to have a single build pass that you have to wait for a big monolith to roll over. With TurboPack and stuff like that, they're looking at bigger, faster monolith, but not necessarily trying to tackle the distribution issue that comes with a monolith, no matter how quick it gets.
Thank you. A big clap. Okay. That was good. That was good. Okay, thank you so much. That's the beauty of having the guy who built the Module Federation in your meetup. Okay, thank you so much. Next speaker, we have Dima. I will tell you when to start because we have the slide with your face on the screen.
Slide with your face, okay. He said to wait. They deploying something most likely, and I will check microphone. So like, I will try to speak into the microphone thing. If I will fail, remind me about that, because I often do that. Both. While technical team is working on that stuff, so we'll start with kind of don't waste the time because we are delayed on the start. So I believe there was a slide with my name somewhere. I can do it differently, you know, just like distributed model federation. They will get back to that. We're gonna speak about model federation and X and next stuff. I would love to touch a couple bit of things about Turbo Packet, Turbo Repo. They are developed in pretty much appropriate way, and they're guaranteed to work only with Next.js. While in Nix, with Nix you can go any direction you like, and any set of frameworks whatsoever. You're gonna fix it?
Yeah, I will fix it. I think it's getting fixed.
Okay. So basically what I'm saying is NX give you much more flexibility in terms of what you can choose to work with. And Next.js overall is a Vercel company, part of the Vercel company. So whatever they do for Vercel. So if you are not a part of Vercel ecosystem, and there are big chances are that if you are trying to go to model federation, there should be a point where you're going to start. And that's not necessarily being a Next.js, right? So, but going with an X, you definitely know that whatever you choose for the front end, or you have already that a part of an X, or there are some kind of additional like open source plugins for Narwhal and X which do support. So for example, if you want to try RSPAC, and I do highly recommend to try RSPAC, there are Narwhal RSPAC module, which is not a part yet of like core, all of the things, but it's already available out there. You can install it, has generators, it has a RSPAC version. Currently folks working on doing like nightly builds to check that everything works properly together. And like in terms of the speed, like we had a joke that if he was doing like NX serve with RSPAC, it will be like sub-second to run compared to Webpack because it's much faster. And on the other hand, there are like configuration with Webpack and RSPAC almost the same. So that's a great thing to have. So we switch back to Zoom. Okay. Yeah. Just. Okay. So the entry part, I suppose, is pretty much done. This talk will be, I can skip some parts because there was already mentioned parts. And there will be one more talk later today related to model federation and version of the deployment. So I will like pay a little more or less time to that part, but that's still very critical. And I have not started with self-introduction because like I do believe that doesn't really matter if you don't have a context. We're not gonna speak about like small application. We had a great talk with you today that if you have a small applications, like using model federation doesn't really make sense for you because that's using like Tech only for the sake of Tech. It's not really great. Yes, we can hype, but it doesn't really make sense. But if you kind of work with the teams where like have 50, 200 developers and it's monorepo or something, you have like 500 commits per week, your PRs are just going ages to review and merge and all of that nice things to have. That's not great. That's then some that moment when you're like, or I'm quitting this company, or we should do that somehow better, right? That's the point where like, or one way or another. And when you're like another part, when your builds start to crumble, right? Because like on some company we had not so long ago, they have split even their monorepo into like, I suppose 7 parts. And total, like, but to run all of that, you have to build all of that, and it takes 3 hours. It's insane, right? So, like, would you work there? Definitely not. So, model federation milestones, worth to mention. I had the pleasure to work with model federation and Angular when it was not yet on release. It was related to SAP requests, and I was a person responsible to merge support of model federation into Angular CLI. So in order to do that, I have to compile Angular CLI and Angular on my machine and run from zip files with like zip files of Webpack. It's really interesting kind of thing, but it was working since like 2010, like June, and it's great because even like all of those crazy betas right? That was working like only in 4 months it was released. And I don't know when we have started to work together as partners. Like he's more like React side, I'm from Angular world, but I'm doing Next.js for money now. So for the last couple of years, nothing personal. So interesting part here that I was somehow lucky since that time to be a part of, as a consultancy and helping to develop how to integrate model federation into teams. I would say like teams, like products. Products is just a representation of our teams, right? Of our organizational structure, like Conway Law, hello, and all of that things. So I was a part of, I don't know, like 10, 20 already organizations and companies where I do not only consult, like, do that, that's great. No, I was there coding with folks in order to implement that. So, you know that person when somebody comes outside and starts to propose new great things, there are always a team who like, nah, that's kind of crap, like you're gonna fix it, right? So there will be presentations which will speak about microfrontends, great, and all of that stuff, but we will speak about much more interesting stuff, which is like the bad, the good, the bad, the ugly, because you should understand the price you're gonna pay and most likely how you're gonna, right, fix it. I will have some assumptions, hopefully they're right for this audience, that you have seen microfrontends, you do on a previous presentation, right? You have heard of model federation, hope so too. Used NPM libraries, and under, I mean, you used NPM libraries, not just installed them, but at least try to build one. Updated package.json, don't be smiling about updating package.json, I have people who know that's an issue. Heard of Phoenix and SDLC, which is software development lifecycle, which is important for you because the way how we speak about model federation always relates to our way of how we plan, develop, and then release. Like speaking about model federation out of the context of SDLC doesn't really make sense because that's the way how our team can work. And have seen Next.js advertisement because not everything they kind of promise is true, but there are still parts which actually works. It's used here as a sample of a framework. So if you'll replace here Next.js with something like Next, Angular, or CityJS for Quick or whatever, those are frameworks, right? Some part of here, like slides now, we can skip, but what this means for is that we say microfrontends and we say about like bright reasons to use, right? So if we say like large-scale application, we do mean that it's unmaintainable crap, right? So when we say autonomy and ownership, we mean that we are tired of politics of other teams that we are not able to do improvements to our application. Kinda, right? So we have to say like technology agnostic, and we can use React and Angular combined with model federation, different versions. Kinda can use, but we're not gonna do that because that's gonna be slow, right? Then we do like easier updates, whatever. What do we mean? Like when we say like we need to refactoring, bundle our versions, like we need to spend time to like we need 2 weeks to upgrade our application, which nobody gonna approve, right? But if you're able to do the same stuff in 1 hour, you will not even create a task for that, and you're gonna do that, and that's what you can achieve with microfrontends, right? With maintenance, we mean that we are able to update our code to some state where we are proud of it, at least some bit, right? Incremental development, it's pretty much multi-repo, and big teams is you can merge your PR in 1 week and not take a month to do that. So, model federation on top of microfrontends or close to it, right? So we say about content, code sharing. And under code sharing, we mean 2 huge parts of that. We mean containers, which actually the components which you write, and there are second part, your containers using some kind of libraries. I will pay a lot of attention to libraries here because superpower of model federation comes from shared libraries. Because there are one questionable thing of model federation, sorry Zach, it's performance. Because there are no proper tree shaking of model federation. You know, yeah. But yes, we're working on reverse tree shaking, but a separate story. But At this moment, model federation doesn't have a tree shaking. So if you want to have really good performance, you're going to do two things. Share as much as you can libraries between containers. Secondly, try to deploy it to edge. But going forward, independent deployments. Very important here is independent deployments. Like difference between monolith and distributed monolith, right? There are no different, like it's amount of repositories, but you have to, like you have many repos, but you have to deploy them at once. Those not are micro-frontends, those are not microservices. This is distributed monolith. But if you can independently deploy your kind of mini application, and it will be consumed properly, then you're going into micro-frontends. Independence here is a factor. Separation of concepts, concerns, whatsoever. When we say that, we mean that we are able to properly split our code and organize it into a predictable fashion. So if you have many similar applications, you open any application from those like micro-frontends, and you know where to look for services or look for, I don't know, pages, whatsoever. So if we speak about React, that could be very surprisingly places where you're going to see them. But if you speak about things like Angular, Next.js, CRA, NX, whatever, you do understand that they have code organization, and you open that repository, and you know where you're going to find that stuff, right? Which is great. Then goes micro-frontends with model federation, which is best friends forever, obviously, and incremental adoption, which is, I call enterprise jailbreak, right? So you have a monolith, and you need to somehow start to bring model federation. And because it's easy to start, and we'll get back there later, it's really enterprise jailbreak. Because just to add model federation support to your monolith, especially if it's Webpack, it's not that a big of a deal. And then you can start to inject something outside. And that allows you to, especially for enterprise, we're going to get there, that when like enterprise buys another company, usually what they do is they spend 2-3 years of money. They buy something for $1 million, then they spend several years to actually adapt that to their tech stack, and then only then they're able to use that, right? But with model federation, what they usually do, they easily inject, like they have the monolith, they add model federation support, they buy something, they took one page, one small part, don't rewrite all of the application. Like in 2 months, they have their first page, they're able to inject from what they have bought. So this is called return of investment, and it creates like a huge leap, right? From 3 years, you go into 2 months in order to get first return of investment, which is great. Oh. And of course, NX, I'm gonna skip the most part of it, but I wanna to pay attention to several things. When we speak about huge teams, and those teams are split into smaller ones, there are one word which is kind of like, okay, 2 words, second one I can pronounce, but scalability, right? So if you have an approach, you have a model federation, and you want to scale that approach, how are you gonna do that? Write a documentation. You can write a documentation, but you cannot force people to read it. That's the tricky part. So what are you gonna do, especially with NX? You're not gonna write the documentation. I don't do. I cannot. I'm writing for computers. I cannot write for humans. That's just not works for me. There are a couple of things which you can do to make the way how you work actually scale. Generators and executors, because generators basically it's a template of some folder of the component of the model federation configuration whatsoever, and executors, it's how it's going to be executed. Like in PM Yarn whatsoever, it's also executors, but there are more complex stuff. When you have to provide configuration for development or production or something special, like for example, if you have an application and you have Webpack build, right? That's executor Narwhal Webpack. Then you change executor to Narwhal RSPack, and it will be executed via RSPack. And nobody inside of the application or the team not going to know that it's actually now RSPack, only because it's faster. Because executors are something else in terms of configuration, and it's a great deal. On top of that goes like a separate part about the migration itself, which like was touched a bit, but should be touched even more. Because like when you need to share your approach with everybody, that's something which is going to win you, because you do that pretty much once, and then people do like one command, and I do recommend you to make that part of a command as a part of your dependabot script. So when dependabot look that you have a package update, make it run and migrate that package. And then you magically happen not only package JSON change, but you actually changed your code if you did migration in AST, which is kind of insane. Then you have a PR, which has package JSON change, it has code change, and it runs all of your tests. And you're more confident to merge that, which is kind of really great thing to share parts. And we will skip most of the slides because it was in previous presentation, but okay, whatever. Next.js, in the context of micro frontends, not model federation itself. We spoke about importance of several things, right? Consistent dev environment. You go into any your micro frontend or model federation container, you know which commands to run, right? Because that is knowledge sharing. It's not even knowledge sharing, it's a simplifying thing. You know that you go into any your microfront, you do install, you do start, you know there will be Nix, it's gonna run, right? Any framework comes with conventions. That's a funny story about React and Next.js, right? Everybody loves React because it's not opinionated. But 16 versions after, they so tired of this freedom of choose and working libraries, like to combine all of that crap to make it work, that like when Next.js came, like, okay, we have a set of libraries which actually works together properly, like, but we API-nated, there are like a folder structure, like we rewrote loadable, like called that Next Dynamic. We rewrote some else from ecosystem, and it's now like TurboPack, Turbo, whatever, but it actually works all together. So framework with opinions, it's actually somewhere good, right? And when I said like Next.js framework, opinion, conventions, Angular, same thing, Quick City, same thing. They have a conventions, which is great. Be careful though, like some conventions which work for Next.js, not gonna work for model federation. Code organization is pretty much a folder structure, where you know where the things are. So you have a standard already somehow between your applications, and your people, when they move from one another, they can understand that. The bad part is, of course, vendor lock-in. That's something we started to speak before actual presentation started, because Next.js is developed in a bit of that word for one particular company. So it could be hard to then eject like Next.js from your React application, right? Because you have all of this next dynamic, next image, next something, which became like, you have the React lazy now, right, or something, but you already have a next dynamic, which does exactly the same thing, but with loadable. It was loadable before they wrote it, but you know, that's appropriate development. It's kind of good for some time, but sometimes you get tired of that. So, getting back to this slide, all of these tools all together, right, are designed, if they're used together properly, they pretty much can resolve the issues which we spoke and give you some benefits which everybody hyped around, right? So you can split, you can micro frontends, you can do the stuff, like, sounds great, but you heard this many times. But then you came back from from a conference to your team and like, I have a great idea. We're gonna split this out, right? And we're gonna do like model federation micro frontends, everything in X. And then you have your like very senior architecture people or whatever. This is very old joke, right? But it works, so don't touch, it's enterprise. We should not do like maintenance whatsoever. Yeah, unfortunately. But like, what we want, start with the good part. Like, we want to work with a modern tech stack, right? Because our brain should work. To make our brain work, we should feed it with new stuff, new information. We are not kind of robots to repeat the same stuff all over again, right? We want to have a quick builds, because waiting is skill. That's why like, they asked me to wait. I cannot wait. Like, I don't have ADHD, or maybe I do have, I don't know. But I hate to wait. It's just killing me slowly, because if I have like a project which builds more than 3 or 4 minutes, I have 2 or 3 projects in parallel do something. I cannot wait. It's kind of killing me, right? We want less politics. We want to do stuff, like to bring interesting features, to bring new fixes, to try something, learn something. Like, we don't want to work with legacy code, right? We have another Zach, he does commits, that's how I call his commits. And we want to make interesting tasks, something which makes us exciting. And then we have a business. Like, business has two main features that they want, like earn more money, less money, right? But taking that seriously, like Zachary on review, like, why you have two same slides? I'm like, yes, they say same two slides, but in different words. What business do wants, or kind of, they doesn't know that they want that, but right? They call it time to market, like quick feature delivery or quick fix delivery, right? Because those two parts, when we are roasted for not being productive, but when your build is 3 hours long, how could you be productive? You have to wait 3 hours while it builds. Like, yes, I fixed it. It's building. Next building, most likely. So, there are downtime, because downtime is money. Who was in downtime, which costs a lot of, I would say, like, people who know how shit ton of money can cost downtime, always trying to make some kind of quick rollbacks or something like that, because they don't deploy once, they deploy 2 servers and then switch. They don't deploy on the same server again. It's like a bad habit. And something which our business doesn't know, but they actually want that, because it's, again, helps them to earn more money, is a spin database. But before we dive. Both, actually. Hopefully I will be able to finish this talk before we die. I'm sorry. Model federation is not Webpack exclusive, right? There are not only native federations, there are like other approaches, and there are like model federation friendly, I would say, approaches, and especially for Webpack, I suppose it's in development yet. But take a look on this one, which is Universe. So both two model federation kind of space and organization is under sometimes available Zachary Jackson review, somebody not. About the Universe part, because model federation is Webpack plugin, right? That's just a plugin. But then you want to use this with Next, with something else, you want to use this with SSR, it's not gonna work from the box just as a plugin. You need additional, most likely, plugins or like NPM libraries to make it work seamlessly to, like, you know, do less and have more, right? That's something similar with us in business, do less and earn more, right? And second one is model federation examples, which we covered mostly with end-to-end tests now, because we are developing those plugins and we should be aware if something goes wrong. I don't know, there are almost 100 of different combinations of libraries, frameworks, and versions of our plugins which are used, covered with end-to-end test. So if you have a question about like how this combination of framework library gonna work, which plugin from model federation universe I need on top of like just model federation, like second repository, and that's something where you can find it, right? So, you know, there are always a person who like, everybody excited, and there was one like bad person who was like, but it seems it's not gonna work, right? That's usually me. So everybody just loves me about that. So how's like typical model federation trip looks like? You know, each time I hear an idea from enterprise, we're gonna try model federation. I'm like, yes, love that part. Let's start it. So first step, usually, right? As I said, it's really to add model federation to your application. But then you, like what we speak about, like code organization, sharing standards, and all of that stuff, that's something which you have to keep in mind. You don't have to do it like as a step up front, but that's something you have to keep in mind. Like in a kind of architecture application. You heard that your application has an architecture, right? So you keep in mind there was an architecture. You have never seen that, but it should be there, right? So when you add model federation, you should understand how you're gonna add it. Or it will be shell application, or it just will be regular application, but configured as host container. Doesn't really matter. There are differences on what this kind of, one way or another, you will have a host container. The difference is how do you understand what this container gonna provide to your remote containers. You have to define, now we go to particular parts and entry point. Responsibility of entry point is to define which remote containers will be injected by URI, right? A list of URLs to inject, which is interesting. Then you have to define on a host container shared libraries. A list of shared libraries which are going to be shared in between host and a remote and between remotes. And as I said, it's very important for your performance. But you develop host and other team develops remotes. So you're going to know. Next funny thing is routing. Yeah, because we get used to, we can use routing from any part of our application. When you go microfrontends or model federation, that's not true anymore. When you define and share state of your application, you can try to use something like Redux or whatsoever. You have to make it as a shareable singleton library, but you will have a joy of name collisions, which is kind of separate.
I hope you are having a lovely time at the conference in person.
Then you have some kind of authentication. Now you don't share just the UI components anymore. You actually share independent functionality, which has a front end and a back end. So you combine microfrontends now, which are deployed on different names, URLs, and actually should be authenticated somehow, each of those. But only shell or like root container is actually mostly responsible for this authentication process. Or you could have a micro frontend who is responsible for all that stuff, which is then shared, could be. And usually, but a small part, usually your remote host container defines the layout of your application, which is again, could be layout, responsible like layout container, could be just another micro frontend, whatever. The fun part, which we get here, like we had a huge enterprise, right? We need to work with that part. And the easy part here to get is that we configured small model federation host, and now we can attach a container, which could be built completely independently, which saves us a lot of time and effort. So all of those benefits of micro frontends and model federation could be gained with a small kind of effort, right? Almost like that. So the caveats, which I told just a bit briefly on previous slide, that you have a hard-coded list of remote containers. Remote containers most likely going to have their production stage and development environments, which you're not going to be able to consume because they're hard-coded. So you will have to think about that, right? And those are defined or dynamically at runtime, but most likely not. That's webpack config. So it's defined in your build time. And it's going to be fun, right? Because there are some things which has to be shared as libraries upfront. For example, styled components, if you will try to combine host and remote and you don't share style components, you don't get what you expect because there are two different compilations, and then you have HTML compiled with one styled components with some classes, and your CSS was provided with a different one. And for some different, for some reasons, they did not match. Cool beans. Hardcore and shares as devs via config, which is you have to actually hardcode that stuff. Knowing and defining all of the libraries which are used by your application, by your remote containers could be tricky because we speak about independence of our remote containers from a host, but then we say we here in another team have several libraries which we're gonna use, but we cannot use that because we have to go to the host team and say we are gonna use some additional libraries. Please add those to configuration because until you're gonna install that on a host, you're not gonna be able to use them here. So they have to rebuild monolith and deploy new shareable libraries, and then we can deploy our new remote container, which sometimes happen that we just deploy our remote container in 2 days. You have 2 days to enable those shared libraries. So that's kind of politics from a different perspective. And one of the things which could be tricky for a host container is enabling communication between remote containers. Yes, because you have remote containers which doesn't have a shared application state. They have different application, and sometimes they're actually dependent on each other or have to provide additional information in between each others. And your host container have to somehow enable them to communicate. And there are many ways to do that. All of them are painful. So no spoilers here, that's something you're gonna find out on your own. But even buses is my favorite way of paying to make this communication work. So routing caveats. Now, as I said, like you have like before that you have an application and you could use routing from any place of your application, right? Now remote containers should not do that because remote containers are attached somehow to a host, but they don't have an access to routing, and they should have a zero knowledge about their host, correct? That means they cannot do navigation. That means you have to develop contracts in between your remote containers and the host application in terms of how remote containers gonna request navigation to some another part. That's a contract of communication, right? We will remember this part, and this will be interesting. But this even painful part about the routing gives you very interesting thing. It gives you a granularity, which there are like important thing about model federation that you do expose this. You split somehow even those parts which you expose into independent parts, right? And here you have a granularity. If you know that your container cannot have more than one page, you know that you will export page by page. And then you will have a contract to the host that there will be a particular container responsible for routing inside of you. Then the host container gonna include you, will take a look on the routing which you provided, and will be able to manage the routing for your remote container. Error handling is a separate kind of interesting stuff. Again, if you have a monolith, everything under your control. Now you have another failure point. Your remote container could fail at loading time. That's not a big deal, but only if you're on React 18, for example, right? So the good part about that you have now suspense, you have boundaries. One failed container doesn't fail your application, which is a good and a bad at the same part. The good part about that whenever you work with remote stuff, and somebody broke their container, it does not break your application. On the tricky part, if you want to provide a user human-readable errors from a remote container, because remote container has its own API, it has its own user workflow, it has its own ways to fail, like in a predictable manner fail, right? And somehow has to communicate that back to host application, and host application should have unified way, like in terms of UX, unified way to show that error to human, so human knows what to do. And that's another point where your best solution here is to actually build a contract of communication between remote and host, right? Which sounds as a standard of communication of your containers, which is actually standard of communication in between your teams. And there will be one team which is responsible for host eventually, which will be a platform team defining the standards of developing your application, even if it's distributed, right? That's why technology agnostic, kinda, because you have your sandbox where you can play and deploy, but there will be shared standards, and to make those shared standards apply to most of your small micro frontends, you have an X, right? So you have an issue and you have a tool which is designed to resolve that issue. You have an issue with those huge teams whatsoever, you have a model federation and huge deployments, huge builds, and you have two tools to resolve those issues, right? Which is model federation and an X, right? Moving forward. An issue which I don't know better sample to like resolve is assets, right? You pull remote container has a CSS or image tag with source, and there are like good and bad. If they use absolute URLs to where they are deployed, you are fine, because like image assets whatsoever, they're gonna work. If they use relative passes, 2 minutes, great. If you have relative passes, you are doomed, because now you have to work with code. You have no idea what it's gonna be. Like, you have an URL, you're gonna inject that, and you're gonna suffer from that point, because you need to know how to actually, like, random code appears on your page and it should work properly, right? So there are several approaches. One is that you are able to actually provide a base URL from host to remotes. When you attach that, it's just a component, so you can provide there some configuration. And again, you build a contract on how should be displayed or used assets, which is good. Secondly, if like it's completely unpredictable, uncontrolled remote container, you always what you can do is to actually attach additional HTML, and you're able to decorate that HTML with some on errors handling, which then tries to, it knows, you know what container you wrap, you know where you get it, and you can wrap it in order to try again and to like change the URL to a proper one. So deployments, that's why I said like versioning will be critical here, because like remote entity.js without hashes and name, that's something you will have an exclusion to your caching. But if you version, you have like 2-3 main benefits. First, you have quick rollbacks to previous version of your container, remote or host, doesn't really matter. Like it's instant. You'll deploy something new one, it breaks, you see it on Sentry, you roll back to the version, which container you use, and it works again, right? You have a time to fix that. But on the other hand, now you have not only one CI/CD and deployment environments to manage, you have multiple environments. Now knowing the price, and we have 1 minute, that would be interesting part. Model federation is really easy to start. Hold him, like maybe you will win me a minute. Easy to start is kind of configuration you will bring to your application. You can upgrade dependencies because you don't have one huge parts where you have like dependencies update means your code update, right? So if you have a small scope of your code and you do upgrade dependencies, it's much easier and faster to do your code upgrade. And most likely Unix is gonna have some kind of AST migration which will gonna upgrade it for you, right? Which is great. Blah, 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 blah. So defining standards is superpower, and this is what you need for Next.js, for example. Whatever you generate, and the first line is how you can generate next application with Unix, just one liner. And pretty much this one will be 5 or 6 additional lines to your Next.js configuration, and this is your host application. That's when I say like it's easy to start with model federation in your application. Secondly, that's my favorite one. Give me 2 minutes, please. And this one is when you're like model federation, there are common confusion that model federation not going to fix your teamwork, like politics, right? Because politics is enterprise is a huge deal. But it's going to fix your teams. Because when I was saying, you will have to develop the contracts of communication between applications. We as humans cannot like split our responsibilities and who is responsible for what. But when we say like, okay, we have an applications and those applications will be responsible for different domains, and now we will set up a standards and contracts how those applications are going to work together, how they will evolve, deployed, and consume each other. That's, we are, as engineers, we know how to do that, right? So our internal politics doesn't really matter up here at this moment because we put this issue in between team communications on a different like level of engineering level, and on that engineering level we are able to perform and we know how to establish that. So yes, it's kind of, you're gonna hate each other like even then, but this approach is gonna work and make you like things you know, work faster, and you're gonna fix it. So I skipped the next slide, you have heard that, but I suppose I have highlighted most important parts. He's tracking time. Skip Next.js here because it's framework for you. It's not you for a framework, it's framework for you. So we spoke about Next.js, about the core organization, that it has a lot of tools, it has ecosystem built for it, and you have a shared libraries, and it has a standards, and it's predictable, right? So that's what framework has to give to you, right? And this is great because when you choose a set of tools for your path to easily move in from your monolith to Microfrontends Model Federation with next whatever. You choose the framework, and you have from the tool belt you choose 90% of the things you're gonna need. There are one small piece which you eventually will find out that you somehow need to understand what's happening up there. Because if you have control only on like some container hosting remote, at some moment you will gonna lose which versions they use, where they deployed, what other versions do they have. So, and this is kind of one of the tools. That's kind of, it's emerging market, right? So that's one of the tools which is gonna help you. Almost 2 minutes, so. Thank you so much for your attention. Thank you for coming, and hopefully that was at least somehow interesting.
Thank you so much. So now you can have pizza and ask him questions. And?
Why you rushed me? I would say like, eat pizza, I continue to talk.
Oh yes, if you want, you can have pizza and you can talk to him. You can continue talking, right?
Yeah, sure.
Okay, thank you so much. Guys, a big clap.
I'm not there in person, hence the video. I'm so sorry, I wish I could have been there. But I live in France, and our country at the moment is on fire. Everybody is doing strikes, you see riots, things on fire, the garbage is not being picked up. Trams, buses, trains, nothing is going. Even planes are cancelled. So I really tried my best to book my travel to London, but it's like the biggest strikes of, since World War II. So it's hard to do. Anyway, so let's act like it's 2021 again. We're going to do a video for our conference talk. So today I want to talk to you about how to sniff out the glue code monster. And yes, I actually said the glue code monster. So let's talk about what that is. But first, my name is Tim Bennix and I'm the Director of Developer Relations at Uniform. And actually at Uniform, we are battling the glue code monster. But how that works and why, we'll get into it. So I work a lot in our community. So I'm an ambassador for things like Nuxt.js, for Algolia, for Supabase. But I also work at the Mac Alliance, where I'm a member of the technical council, where we talk about what is Mac, what is headless, all these things. And so my accent is a little strange. That's because I was born in the Netherlands, but then I live in France and I work with Americans. And so if anything is strange, this is why. So let's get into it. So the modern tech stack is actually pretty awesome, right? But when you start scaling it with all these headless systems and your fancy front ends, it's getting really challenging at scale. And so this is a bit controversial, but I don't think it's going to work when you do really big projects with all the modern tools. So let's talk about that. So essentially, you are the composer of your stack. You're the developer or the architect or the product owner. And so you just grab a collection of the tools that you love, put them together, and then make your channel, website, iPhone app, whatever. But just combining these headless sources doesn't mean you're going to be successful, right? It's not a composable architecture out of the blue. You kind of have to work at it, and generally that's really hard to do. So imagine you tend to start with your CMS, right? Or maybe with your front end, and you kind of connect them up. This is how you start small, but let's imagine now that we're going to do an e-commerce that's going to grow globally over a year. Well, the moment you feel the need for performance and growth, you're going to add a certain types of products. So in this case, we're going to add Cloudinary because images at scale need to be presented fast. You need to be able to crop a face or a product or something, and Cloudinary is amazing for that. And it's also a DAM, so you can store your assets there. So you need to connect everything up. Well, then you might need some search, right? Either for searching a product catalog or whatever, a blog, things like that. So that also needs to be connected because all your Algolia index needs to be filled by a few things. Well, here is your commerce, let's say Shopify. Well, your Shopify needs to be connected to your front end. You need to be able to go to, let's say, a checkout, a bag, things like that. But it also needs to be connected to your CMS, because how else do you grab information from your shop, put it in a page on your CMS, and then show on your front end? All the images need to go there. Your index needs to be able to grab all your product information so you can search your products in a really nice way. You need analytics. You actually need hosting. And then all these services likely have to be connected to this hosting CI/CD stack provider somehow to, when something changes, trigger a new release or do something, right? And so you're going to see a change here means a rebuild, or I don't know, whatever you want to do there. And then, of course, when you grow, you probably need something like HubSpot or CRM-like capabilities, because you might want to send emails, campaigns, whatever. That also has to be connected everywhere. And you see how many things are actually now started to connect. And this is relatively basic. Normally, bigger projects have way more than just this, because they might have legacy APIs and other things that define their business, right? And then the real thing starts to happen. You grow, and you have, let's say you go from Europe to the US, and there they just like a different CMS because something is already built. This is the realistic, scenario. So let's add in a new CMS and let's connect it to everything. You see how crazy this is starting to get? How you are cloning connections, and like, how are these things connected anyways? Do they have app stores? Do they use serverless functions that change data? It's starting to get a little bit mad, to be fair. And so I dare you, try to switch out one of these services because they don't work, or add something else while the thing is running. This is going to be a pretty bad time, and you're going to be this as a developer, right? You change one thing, another thing falls over. How have I integrated this? Oh, I forgot that the dude 2 years ago did this. You're going to be essentially like this guy with this Dyson. This fire is not going to go out. And so essentially you wanted this because you have headless systems. You put code together so it's open, transparent. But after 2 years of like a growing business, you get to this. And this you don't want. And so this is Gludo, the glue code monster. And so essentially, glue code is the thing that connects all these services together. And I mean, we call this glue because it's hard to unstick, right? And so we are able to define if you are using glue code somehow by asking a few questions. So in your mind, think about, or in the chat, just say yes or no if you're dealing with these questions. So first one, do you clean up that messy API response so its data fits your front end? Well, because every API is different, right? And sometimes APIs change, or sometimes a field is just not there. So you need to add some code somewhere to map that data so your components understand it. That is glue code. Or do you just adapt your front-end components to whatever that API gives you? So you add a little bit of cleaning up stuff or lots of like defensive code in your front-end components themselves. That can also work because you might not have like a backend team or an API developer somehow. So you're just adapting locally. And then there's another one. So do you actually mix your domain data with design-related data in your data models in, let's say, your product category or in your product CMS or whatever? What I mean by that is this product is now featured. That adds a checkbox to this domain model so it shows big on the front end. Well, over time, when you keep adding checkboxes and dropdowns to data models, they are muddled with design-related things. And then it's really hard to actually still understand what they're doing. If you remove something, maybe something breaks. And for that, you need a lot of defensive code and a lot of cleaning up and just extra brain power. And we don't want that glue sitting in between everything, that code that you had to make. So if you've said yes to some of these questions, or like partly, even partly, you are probably pretty good at glue code. And it's actually a fun part of coding sometimes. But wouldn't you like to not have to do that and only deal with like the super fun front end or the super fun API creation part of your job, right? And so let's just give you a quick example of what I think about glue code, or like what it could be. And we're doing it with like the most optimistic example. So essentially, let's say you want a list of videos from YouTube, but you want it from an API call from the playlist because you want it curated a certain way. Well, what you do is you query and map the video IDs that you get back, because there's a lot of other data in that playlist API that you don't need. You just need a list with videos, right? So you have a bit of memory where you have an array with a few IDs. Well, then you need to get the information about these videos. Well, then you just go to the YouTube video API. What you do is you query for each of these IDs, you query the API and you get more information back. But it's kind of a lot that you get back. You don't need it, right? You only need maybe the ID that you already have. You need the title and the image. Maybe that's enough for now. And please correct me if I'm wrong. It could be that the API actually works a bit differently, but this is just an example. So what you'll do, you have a few calls, you clean it up again, and then in the end, you come up with one list of what you use. But YouTube or Google's APIs are really solid, right? Everybody uses them. They're cool. Imagine if this is a less good API. Imagine if it just changes, or if a field suddenly doesn't exist, if it's empty. You're going to have to do a lot of like defensive-like coding, cleaning up things, and if it doesn't exist, you fill it up with mock data, or maybe you don't. That is a lot of messy code just to get this list of videos, right? And what if you have to go to Vimeo suddenly? What do you do with this code? You just toss it away? It kind of feels a bit icky to have this. So, glue code is a highly defensive code which fetches data and cleanses it, right? And so glue code creates technical debt, and it tight couples specific code to specific services. And sometimes that's fine. You need a little bit of glue maybe, but too much glue and you cannot change anything anymore. You cannot adapt, you cannot innovate. And the more tech debt you have, the slower you get, the more upset your developers, the more developers leave, and suddenly there's no longer a team.
Boy, that escalated quickly.
Now what? We need to get rid of the glue code monster, essentially. And so there is a way. And so the way to unglue this whole system or this whole approach with all this crazy code is something we like to call digital experience composition, or we call it DXC, which is yet another acronym we're throwing in your faces here. I'm sorry, it's yet another one, but this is actually something that, to me at least, having worked with these large systems as a developer lead, it changes the game. And even if you're a junior developer or you don't really understand all this yet, this is a thing that's going to help you going forward. So essentially, right now, when you don't have DXC, you're the guy on the left. Or maybe your boss is the guy on the left who sits on the pile of all the cables, knows exactly where they go. But what if this guy is not there? Do you know how to find these cables? How to untangle one thing? It's pretty hard, right? And so what DXC does is actually give you the thing on the right, which is still hard to understand, but it's a lot more organized. And it's more friendly to different disciplines, but we'll talk about that later. So essentially, this is how you would build a page nowadays. Let's say this is your page. There's a hero component with a campaign, and that's connected to a CMS. Well, maybe the image comes from the DAM system. Then you have another little component which is connected through Algolia, because potentially this is just a search result or a personalized thing that's similar to something else showing on the page. And then there's a product where the image comes from the DAM system again, and then the product is selected from Shopify. So you see how many connections are on one page here. What do? You have to kind of connect to them from the front end, and you kind of code all these things together. That's pretty messy. It works, but why if you change one thing? What do? Your content editor is going to be calling you. It's like, hey, dude, can you just change this thing? I want to have like 5 products here. And you're like, yeah, but I have to code something. And of course, there's in-between solutions, but this happens more than you think. And so the DXC, the digital experience composition layer, sits in between here. So all these systems, they actually connect to the DXC, and then the front end connects to the DXC as well. And that kind of sounds like an API aggregator, but it's actually way more. Because essentially, if you do this right, you get preview of your page independently of whatever is connected to it, right? You get freedom to choose your stack, because if there's one endpoint, you can go to, Next.js, Nuxt. Maybe we go Astro, because why not, right? Island architecture for the win. You get to choose, it doesn't matter. This, of course, is the same thing as if you did it another way. You can always choose what you want. But here, if you wanted to, you can go to SvelteKit in 2 weeks if you have the time to rebuild, but you then actually don't have to care about how it's connected. Anyways, because you have all the sources here, you can actually add something like personalization, for example, without having to worry, how do I do personalization in Shopify, and how do I do it in my CMS, and how do I do it in my search engine? You can actually do that across these systems without a problem. And the beauty is, if you do it right, which I'll show you in a sec, you can actually have a no-code editor on the front-end side of things that is agnostic from how you do all your code. And so content editors will be very happy with you for once, right? And so this is the traditional page. And here sits the DXC around it which will then essentially just connect to all the services for you, and you can talk to the DXC, and it's a very light SDK, which is very interesting, right? You suddenly have less to worry about. And so this does give us a new way of how we create pages, like the separation of concerns between where data lives and where design lives, where your design-driven system is actually different. So we should talk about that for a sec. And so we have domain data versus design data. And in a DXC system, this is actually separated out much more than you're used to right now, because such a system doesn't really exist. Well, there's some of them, like a backend for frontend has part of it, an API aggregator has some of it, a monolith CMS has some of it. But in this case, we separate it out more. So domain data is the data that defines your brand or your customer's data, your customer's brand, like products. They sit in one place in a product inventory system or whatever you want to call it. And you can use those in 10 years, or you can use them next month, and they keep being enriched and made better, but it's very clean data. Your design data, however, sits on your front end, and kind of you want to maybe make something featured. You do that in your front end. You add a checkbox in your data model in your design data. And so an example could be, imagine you have an events website, right? Like City.js. You guys have a ton of different events in different cities. Well, the event data sits in the CMS, like venues, speakers, addresses, times, whatever. It is all data modeled, really neatly data modeled in your system where that's supposed to happen. But now it's City.js, right? So last week on the website, you're going to push for City.js London. That's a featured event. Well, what you would do without a DXC is you go to your data model in your CMS and you add a checkbox for it's a featured event right now. And you maybe add a drop down for make the font a bit bolder and make it a red background because we can. And over time, the more and more this happens, more of these little checkboxes and drop downs come in. And so what happens if you kind of see this event in a different context? If it's in a search result, these checkboxes make no sense, right? So you're dirtying up your domain data. And so when it's bigger and you have a multi-tenant operation, somebody in Malaysia might say, I don't need that checkbox. Let me just remove that because I'm cleaning up my data model because it's hard to edit and understand. Then somewhere in Germany, your website is just dead now because the data is no longer there. This causes you technical debt, glue code, complicated stuff. So what you do is your domain data stays clear and you have another system where you do all your design related stuff. So things like featured event, that's a title that makes no sense in CMS because it has no context. It's just a little string. But when you put it in your design data for that page, in that context, for that week, it makes total sense. So all the checkboxes, all the variants in like how does it look, that's design data that sits in your DXC. And your domain data stays around it. So it's a very clean separation. And so this benefits developers quite a bit. So let's talk about that. So for front-end people, so your components are now completely agnostic. They don't know what it connects to. Your components are design system components, essentially. Your props are your props. This is how it was designed. This is how it's used. You don't have to worry about more than that when you have a DXC. So essentially, you make a front end that is stupid. I know it's kind of silly to say, right? But the more stupid your front end, the less prone to error it is. The less glue code you need to morph things so it fits your component. That all happens in the DXC. You can literally say in a DXC, this is my component that sits in the front end and in my DXC. And these props I need. So you connect the props to an external system in your DXC directly to the fields, and it just goes one-to-one to your front end. Your front end is stupid. Believe me, you want that. And then so when you're full stack, or whoever is full stack, you can kind of, if you want to connect anything to the same way in any front end or in any framework. And so you can basically, if you wanted to, have the DXC map all these props for you directly. Or if you want a little bit of glue, or you need to change something because maybe you have to go deeper into whatever query it is in your CMS and follow some connections, you can actually do that in a really nice way because there's an SDK from this DXC to do that. And so doing things the same way is much easier with unit tests. It's much less brain power. Everything gets better, right? And so if you can choose whatever front end you want, you can host it anywhere. You can render it any mode you want, right? So freedom is cool. And so the agnostic stupid front end is actually pretty awesome. And so this, for example, is my homepage. I recently released this using the DXC from Uniform, because Uniform is actually DXC. I can't believe I'm only telling you now, but it is. And so essentially, let's just have a look at how this was built. So we have the DXC, which is Uniform, and it has a slug to a certain composition, which is this page. In this case, the slash, because it's home. And so this hero component is basically represented in the front end. This is my Next.js code. It's a hero component with a few props that's represented in the DXC as well as a hero component with a few props. And so this now has a Cloudinary image, but it also has like a title and stuff, and we'll get there in a sec. Well, then I have latest videos, which is also represented in the DXC. And for me, I just connect to YouTube, get the latest videos in the DXC, so the front end doesn't connect to anything. Then my upcoming talks, that component actually talks to Contentful. That's where I add these, but it can also be in Sessionize or any other place, maybe Notion, where you just write down all your talks. This just connects to the DXC. Frontend doesn't know. Then you have your latest writings. And in my case, actually these comes from dev.to because I like to write there. And so when I click on one of those, I just go to the external system where my domain data lives, right? And so we still have these titles, right? Latest videos, upcoming talks, Tim Bennix, blah, blah, blah. These are actually stored in the DXC because they are context-based to this design. Because when I decide not to have upcoming talks there, but do something else, that data shouldn't have to live in some CMS. You just type it in. So in that case, a DXC is almost like a little design data-related micro CMS. But it's not a CMS. It just points to stuff. And so right now, this is hosted on Vercel with Next.js 13. And Uniform's data, I chose, in this case, comes from the CDN edge that Uniform has, which means my dynamic data is cached on the CDN edge close to me. So this is an SSR website. And it's rendering in like 100 milliseconds or less per page, which is pretty epic. And so let's see a bit about how Uniform actually stores that stuff on the edge. So basically what you get is there's a composition with a bunch of components in the DXC. Then that becomes JSON. It's basically just a REST API to get all that information. It can either be a pointer to a thing elsewhere, or it's actually all their props already just stored here. And that actually then, talks to all these systems. And then whatever came out of that is enriched, because this JSON composition is initially is just, I'm pointing to some external services, right? Then it goes to the CDN edge, where it actually is enriched with all the information that you need and cached there. And then it goes to your front end. And the front end has a relatively light SDK to just talk to that enriched CDN edge endpoint. And so there is an extra thing though, because you might want to hook in to whatever comes out of Uniform. For example, it could be that for my Cloudinary image, I only get an ID, but I might actually want to get the alt tag. This is just an example, right? So you get hooks in the Uniform SDK to be able to just get the initial data and then query other systems. And then enrich that and then send it to your front end. So if you wanted to add just a little glue just to do the things that you need as a developer, you can. And so this gives you a bunch of freedom, right? And so my front end component in this case is just a simple one. It doesn't know about anything other than these are my props. This is how I render it. Keeps it very simple. If I wanted to change this in Vue, no problem, just works. And so it's not just a backend for front end, but it's also not really an API aggregator because it does a few things more. So I actually made like a little video of how I edit my website. You can see I'm visually editing this, right? So I'm adding a little list here, right? And I want it to be a grid. So let's just fill out a little title. And so this title represents an atom for front-end component in my front end. You see it directly renders. And here you can add loops. And I've added a data model to find my latest YouTube videos. And that data model is set up in the DXC. Then you just assign whatever comes out of that API, you assign it to your props. And so literally what you see on the right here are the props of my component. And so you can set it to video, add a title. Well, in this case, description is not really needed, I think, but why not? You can add the date, and then there's adding the media, and you see it literally build up over time when I add this stuff. And this way, you can add a bunch more things because you can actually add like personalization related stuff, changing things up. So this actually is agnostic to the tech. It just works with this very light SDK. So developers are pretty happy with that, hopefully. But then content editors can visually do this. This is literally my live website being edited in draft mode. When I hit publish, it actually rebuilds or whatever. In this case, nothing happened because it's SSR. It just has to cache on the CDN. And so we went from this to this. It's a lot more exciting and a lot more structured. And it also helps you to, like the thing is, it can be as small as you want because you can essentially just have this old system and slowly start integrating with the new system. And then over time, you just grab a little bit more into the new system and you're good to go. And so this is what I wanted to talk to you about. And so if you're interested in this whole approach and you like what you heard, Uniform is actually one of the only ones to do all this. There's a few other companies touching upon it, like Netlify is going in a certain direction, but only code. You have other systems that touch it, but not fully. And so if you're interested, you can just join our Discord. You can scan the QR code or just go to uniform.to/Discord so we can chat about this because it is a really exciting way for the future. And so thank you very much. If you like this,
ended up with a diagram that's a little bit more daunting, which looks something like this. Yeah, and it's supposed to look a little bit daunting, but don't worry, I'm going to go through each part of it. So I'm going to dive into Excalibur for this. Oh my God, I'm looking at myself. That's terrifying. You want me to share my screen? Okay, yeah. Cool. Right. You can watch me all fail with this. Screen sharing chips. Good. Oh, I've got it.
Oh, you haven't...
I probably have to open thingy to do this.
Yeah, that's fine. So
that's fine. Let me open my system preferences.
So last year you also gave a talk in the previous conference, and it was a bit about Microfrontends. So maybe you can see that as well. What was that talk about?
It was about microfrontends and migrating.
The idea of all these talks is like that we want to show different examples of companies using microfrontends, and I just quite a big corp, and we want to see how do they use the systems. We did the same thing with we have another talk later with Adidas, so we want to compare how do they do it, what do they use. So previous talk we're looking at Valor. And we're looking more of how it can be done. And then next week, on Friday, not next week, is this week, we can see with Zach more about SSR, moving for federation, and we can learn more about it.
Okay.
So
is this working? Is this working?
Let me go back.
People are back. It's all very difficult. I've got to share on two different things. It's kind of beyond me, which doesn't fill you with confidence about my talk, does it? But anyway. Sure, maybe. Is that better? Is that too bright? Okay, cool. Well, hopefully people can see it. Is the stream working? All good? Okay, cool. Right, I'm going to carry on. So I promised I'd go through this diagram. So I was switching to Excalibur just so it's a little bit easier for me to kind of drag around. So this diagram's kind of split into two main segments. Hopefully you can see that. On the left-hand side, we have a vertical team, and you can think of that as a team that's responsible for some sort of complete client journey. Think like payments or account opening, that sort of side of things. They're responsible for like a specific client journey. And on the right-hand side, we have a platform team, and they're responsible. People have talked about a shell or a host application. That's essentially what our platform team is responsible for, things like navigation and authentication. So diving into these segments a little bit more, I want to start with this micro front-end build. So you can imagine your vertical team has some independent deployable, and they want to run through a normal CI/CD pipeline. So they run their build, they run all their tests and linting, etc. And once they've done that, they upload their assets to some sort of static server with an edge cache. In our case, it's AWS S3 with a CloudFront distribution. But we also expect these vertical teams to make an HTTP request to this thing, which is an import map build. So for those of you who don't know import maps. They're essentially just key value pairs where the key is some unique identifier for a micro front end, and the value is just a URL that you can fetch kind of the entry point for that micro front end asset, or any asset for that matter. So we have a build plan that essentially manages that for us, manages updating, and it's sort of the interop point between our vertical teams and our platform teams. So given an HTTP request with some sort of contextual information around what micro front ends we want to update, our import map build updates the import map and uploads it to that same sort of setup, that same static server with an edge cache. And then you can imagine that our clients come and visit our host application down here. They load our sort of host application source into the browser, and then they click around for a while and they decide they want to make some payments. And so we fetch an import map, and we search for the payments micro front end, and from that we get our URL, and that URL points us to that micro front end source. Right? So you can see how all these pieces work together. And for the eagle-eyed among you, and I'm hoping the guy that shouted to be in the light mode is kind of paying attention and can see that I've missed a big part of the diagram. We've got this big section in the middle, which is our internal NPM repository. So one of the key things that we found was that sharing a component library between all of our different micro front ends and our host application kept like a cohesive brand, made sure that it didn't seem like we were building kind of a Frankenstein front end where every single app had kind of a completely different design system. So jumping back to the slides, it's all working, it's great. There's a few things about this that I want to call out as stuff that we found pretty successful. So the first of that is this HTTP request and this import map build pipeline. This is a really powerful way to like allow sort of independent vertical teams to kind of really own their micro front ends and reduce the interaction between the sort of vertical teams and our host team. And secondly, our component library is probably unsurprising that having a cohesive design system makes it a lot easier to build a good sort of web experience with multiple micro front ends. There are a few things that we could have done better. Namely, you saw us go from a very simple diagram to a very complicated one. We went a bit kind of big bang with our micro front end migration, and I think if we were to go back again, we'd probably take a more step-by-step approach. I've got a demo which will hopefully explain how we can do that. But the other main thing that we didn't do from the off was include types. So we were migrating to TypeScript as we started doing this, so we didn't really think about how important the interfaces between our micro front ends and our host application were. But in hindsight, we've had a few issues where we're wondering why we're passing a number when we're expecting a string, all the stuff that TypeScript helps deal with. So the way we sort of manage this is that we'd expect each micro front end would publish a types package to this internal repository, and then our host application would kind of consume that types package. So just to summarize kind of all the diagrams and the ticks that I've put together so far, we've kind of got the good, the bad, and the ugly. We've had that a few times already this evening, to be fair. But the good is obviously that HTTP triggered manifest file and that shared design library. The bad being that lack of type definitions and that kind of big bang migration to micro front ends. And I've also got the ugly here, which I want to call out because it added a lot of complexity to the way we approach the problem and the tools we could use. But I am going to forget about it. So we're dealing with a big legacy monolithic application which had multiple frameworks, and as a result of those multiple frameworks had multiple build tools, and that just limited the kind of technologies that we had at our disposal. So like I said, I'm going to forget about that bit and pretend it's not there because it doesn't really fit with the rest of the talk. So can we take the stuff that's in this bad column and make it to kind of benefits and things that we could do better? And if we were to do this again, obviously, rather than having no type definitions, I'd have type definitions. That's pretty straightforward. But with this kind of big bang migration to micro front ends, what I'd prefer to look at is kind of a step-by-step migration approach where you can first take a monolithic application, move it to a mono repo, and load sort of build time micro front ends, if you like, which are just kind of NPM packages that provide some level of independence for teams, and then make a really easy way for teams to then test out whether a runtime micro front-end model is appropriate for them, but something that's sort of easily reversible so that they can test without sort of fully committing to that architecture. So I've said a lot of words. Let's actually do a demo because I think it's a bit more interesting. So I'm going to show you why I'm not a web designer and why I'm not a games developer as well. So this is Cookie Catcher. Cookie Catcher is a very simple game, which I actually haven't deployed anywhere, but I'm sure I will if you're particularly interested in playing a terrible game that I put together in a few hours. But it's got three main parts. It's got this kind of header, which we think would belong to our host application. It's got this notifications section, which we're going to migrate today in this demo. And then we've got kind of a Cookie Catcher game, which I will play once and let you guys play another time. I'm really shit at this. Last score 4, terrible. Okay, so let's have a look at the code for this. Is this big enough? Can people see this? Yeah? Good? Great. Cool. So our application currently is just a monolith, and it's just a Next.js app. And we've got kind of three main components here. We've got our navbar, like I said. We've got our cookie catcher component, and then we've got kind of our notifications component. And then if we scroll down a little bit, we've got a couple of packages that we're going to move our sort of components to into their own microfrontends, and we're going to be focusing on this notifications one. And then the last thing I want to call out is this microfrontend loader package, which we're going to use to actually sort of load in our microfrontends. And the key behind this is basically this just abstracts away the actual sort of implementation details around loading a microfrontend. So this is something that probably would be done by a host team and would only be done once. In this case, for build time, we're just using Webpack dynamic imports, and at runtime, we're using single SPA, but that's just for the sake of this demo to show that you could want different implementations. And it's easy to kind of abstract that away from your vertical teams. So without further ado, let's actually move this notifications component into its own sort of micro front end. So the first thing we need to do is take our notifications and drag it down to notifications and then in source components. So I'm going to move that. And with that moved, you can see we've got a few relative imports we need to fix. The first one of these is get notifications from our app web client API. So if we go back to our monolithic application, we can take this, our get notifications, and also the type. We'll cut this out of our monolithic app and move it to the API file that I created earlier in our notifications micro front end. I'm going to tell you as well, I also cheated and copied our notification type earlier, so I can just reference that from the types in our micro front end. So going back to our notifications, we can now reference this here. And our types, as like I've already mentioned. And the last thing that we've not touched is our styles. So I'm going to take them from our monolithic application and just move them into our micro front end. Cool. So we're going to save all of that. That's the mistake I normally make, is forgetting to save this. So we've moved our components. We've kind of got our micro front end set up, but we need some entry points. And again, this is kind of just for the sake of the demo, but to show that you can have different entry points for like build time and run time, like front ends if you want to. Okay, cool. I'm being pointed at a watch, so I'll speed up. So for our build time micro front ends, we've essentially just got this entry point here, which is just wraps our component in a query client provider that's provided by the host application, just to help dedupe some of our requests if we want to. We actually don't make any duplicated requests here, but just for the sake of what you can do. And then for our runtime micro front ends, like I said, we're just wrapping that root component in single SPA React if we wanted to support, I don't know, different frameworks, for example. So going back to index in our host application, rather than loading this notifications in, I'm instead going to use our micro front end loader, which I showed you earlier, to create a loader which can then fetch our micro front end either at build time or at runtime pretty arbitrarily. So the first thing we do to do that is call this create loader function, and this accepts a generic, which is our type, the notification props type from our micro front end. So that gives us our type safety between our host app and our micro front end. And then using that notification loader, we can literally just load our notifications in. So I'm going to comment this bit out. And then, yeah, so you can see this notification loader takes a few things. It takes all of the props that are related to the notifications, which in our case is just a query client. It also takes this wrap style just to manage some styles associated with single SPA. And then it takes this app function. And this is the most important thing, is you just pass it a function that can load your entry point, right? So in this case, it's just a Webpack dynamic import. I'm going to show you a very unexciting demo, hopefully, if this is going to load. There you go, cool. So this is obviously exactly the same app, but hopefully now we can see here. Is that too small? Oh no, it's pretty big. Cool, so you can see now, rather than loading our notifications from as part of a monolith, we're loading them using a Webpack dynamic import. Let's say, though, that the team that's responsible for notifications wants to test out using runtime microfrontends instead. It's really easy for them to do that. They just need to update the import map, that key value pair list, and this would probably be done via that import map build in an actual application. So our monorepo probably have a package that helps support that. But for the sake of this demo, I'm just going to literally just type it in here. So it's myorg/notifications, and then I'm actually hosting the entry point just on a localhost port, which I think is 8080. And then I just need to match up here, my.org notifications, my-org-notifications.js. So with that import map updated, we can then go back to our host, and rather than using a Webpack dynamic import, we can use system.js, which will read our import map and import our notifications package. So if I've done this correctly, and I refresh this, you can see now we are loading our notifications at runtime now from a separate URL, right? So it's really easy and trivial to kind of swap between those two. So it lets teams test out what method is most appropriate for them without fully committing to that whole architectural pattern. So I just want to summarize, because I'm conscious I'm going to run out of time. If you are looking at a monolithic application and you want to migrate to a more independent model, I'd suggest you start by moving to a monorepo. Make sure you type your interfaces between your packages really, really strongly. That will solve a lot of problems for you down the line. And finally, make it really easy for teams to swap between build time and runtime microfrontends. So I suggest extracting that loading logic makes that very easy. And by doing that, you let teams kind of test out and experiment with what pattern works best for them, and you don't prescribe some big architectural shift right from the off. So that's all I have. I'm going to finish with a little bit of shameless self-promotion. So all of the code today is available on GitHub, and that does have an example where I've migrated the actual full kind of cookie catcher game, which is a little bit more interesting. You can tweet me if you're interested. I sometimes tweet about microfrontends, and if you have any questions that don't get answered today, you can also drop me an email. Thank you very much.
Any questions? You can meet him also. You're going to be in the conference?
Yeah, I'll be here on Friday. Yep.
Okay, cool, cool. Thank you so much. Another clap. Thank you.
It works. Okay, so hello everyone. I'm from GWI. Come on. And today we are talking about how we learn to stop worrying and love the versioning in microfrontends. I'm Guy Berlo. Friends call me Nambo, similar to Rambo. That's the only joke for today. and I'm an associate director of engineering in GWI. And you will ask what we do in GWI. In GWI, essentially, we are a market research company, and what we do is gather data from 50 countries around the globe, and those data are from 2009, and those data are essentially visualizations. So through Microfrontends, we create visualizations of those data, and those visualizations essentially assist each market researcher persona do their work way easier. Some terminology that we are going to use today is the following. So every time that you see or hear the word MFE, I'm going to refer to Microfrontend. With the kernel or shell, host, platform, whatever, I'm going to refer the system that glues everything up, essentially an app that, in our case, in GWI, it also holds the top menu bar and also our homepage, which is simple enough. Along with it, it also loads every microfrontend upon request. Every time that we are talking about a main branch, we are going to refer to develop, release, or master, or now main, Git branches. Application essentially is the result application of kernel along with all the microfrontends. Every time you see the word BE, we are going to just refer to backend, CI/CD, continuous integration, continuous deployment, an automated way to build, test, and just upload your code somewhere. Environments, in GWI we have 3 of those. It's testing, staging, and production, and they are correlated with the main branches, develop, release, and master. FE configuration, essentially what we are going to talk about today, how we actually do the versioning in GWI, and it's our tool to keep track of all the microfrontend versions, GS, Google Storage, and PR, GitHub pull request. So in GWI, we had the need right from the start to actually connect the kernel along with all the microfrontends in a way that those microfrontends can be easily updated using a single tool and not a chaos of tools, with versions that are instantly uncast in all the environments, right? So back in 2019, when we landed actually in GWI, we didn't even know what we didn't know back then, and we decided for this reason to approach this whole MFE versioning thing in an agile way, meaning that we made small iterations and we inspected, adapted, and made our next step. The result of this approach is this internal tool that I just referred to, which is called FE configuration. Now it's called MFE tool, and maybe in the future it will be called deployment tool. And below is our journey towards finding actually the best way to keep track of our microfrontend versionings by creating, consistently updating, and refining our front-end configuration tool. So the first approach that we had, right when we landed in GWI, we found this. So what was this? The way we used to actually upload microfrontends to an environment was that every time an engineer had created a new version of a microfrontend, they would merge a PR to the microfrontend repo, and then wait for the CI/CD to actually upload this JavaScript bundle to a Google Storage bucket, and it would create actually static content right in Google Storage. So this static content would have the following name, MFE name /asset /git commit ID. The next thing that the engineer had to do was to copy this commit ID, and the next thing was to go to kernel code repository, update this git commit ID, make an additional PR, and then the CI/CD would actually take care of all of those changes and upload these changes to an environment. Unfortunately, this was not maintainable at all, and right from the start, we had quite a few issues. So what were those issues? Every time we needed a manual PR to kernel so that we actually in a position to upload a microfrontend, a specific microfrontend. The next problem was that kernel's Git repo main branch trees were polluted right from the start, so you were seeing Git commits with messages something like updated X component of kernel, updated Y component of kernel, updated MFE1, updated MFE2, updated MFE1, updated MFE. So this meant that actually all the main branches were polluted right from the start. And last but not least, there was a great bottleneck in our release process, as we had to make quite a few stuff to actually upload something in an environment, right? So we said, okay, let's hack something quickly just to make a proof of concept to see if it actually works. What we did, the gist is that we created a Golang-based HTML template, and this template was living in a microservice completely unrelated, right? Just to prove that it will work. And it actually worked. So the way that we worked after that was that we updated single input fields regarding this microfrontend. And what the engineer would do is to get this specific commit ID of the microfrontend. And then when the kernel or host or whatever is loaded, it immediately requests all the latest versions of all the microfrontends for this specific environment. Then this microservice would respond, and then the kernel would actually render the latest versions of the requested microfrontend. And it indeed actually worked, but again, there were quite a few issues. So what were those issues? The first one was that we had quite a few hard-coded values for this to work in a Golang-based HTML template. The second and most problematic thing was that this microservice was to serve completely unrelated data from what we had there, right? The third thing was that the task of creating a new microfrontend in this Golang-based template was quite a hard thing because Golang-based HTML templates back then were not supported by IDEs, which meant we were like just typing in a notepad. And last but not least, there was no ability to create an application actually consisted of microfrontends and reuse this functionality, which meant back then that our team was the only team that it was able to actually use the microfrontend architecture, which was a bad thing, apparently. So the first good approach that we took was approach number 3. And what we did back then was to create our front-end configuration. And what this was consisted of was web UI along with a dedicated microservice. And this approach actually solved quite a few issues. We now had the ability to create applications along with their corresponding microfrontends, which meant that all the other teams in the company were now in the position to actually create microfrontend-based applications. We had the ability to update microfrontends regardless of the environment. We were able to create scalable front-end UI developed specifically with React and no Golang-based HTML templates. I mean, okay. And last but not least, we did have various micro-frontend properties that were now dynamic and scalable. The issue with Golang-based HTML template, the approach number 2, was that we had quite a few hard-coded stuff. And the fact that we now had only dynamic variables per micro-frontend was something like an ecstasy back then. So that was the very reason that we actually named our whole solution micro-frontend configuration. So the way that this worked, similar to approach number 2, was that the kernel or host or whatever, when it actually loads, it would make a request to the front-end configuration service now. And then when it would get all the latest micro front-end versions, what it would do next is upon user's request. So if the user, let's say, would like to have access to this one, to this micro front-end right here, it would actually go to Google Storage Bucket, fetch the JavaScript bundle, and render it in the dedicated placeholder that we have right here. Yet again, we had another thing that was missing. Actually, quite a few things. So what were those things? The first one was that there was no list of the latest versions per microfrontend, which meant back then that there was no easy way to actually just roll back to the previous version. We didn't have the ability to have long-lived feature branches to test out stuff. There was no usage of already implemented design system, and there was no maintenance mode, either per microfrontend or per application. Essentially, in ZWI, what we mean with maintenance mode is restrict access to a specific microfrontend, to a specific application, and actually, in approach number 4, also restrict access to the whole API. So what we did in approach number 4 was to make a completely revamp of microfrontend tool. We actually utilized the GWI's design system. We introduced the support of feature branches. We were now having the latest versions per microfrontend for easier rollback, as we just said. We now gave the ability to provide backwards compatibility because all the other squads were not already updated to our latest version. So we want to give them time and space to do it in their own time. And last but not least, we also implemented maintenance mode per microfrontend and per application and per API service. So what are feature branches? So according to Atlassian, the core idea behind the feature branch workflow is that all feature development should take place in a dedicated branch instead of the main branch. What we did in ZWI is essentially match this feature branch code to a specific UI. We also would like to deploy this to any environment at any point. And this UI should be accessible with dedicated URL. So what we did is that we would like to access certain feature branches in certain environments, and this was the way that we did it. We provided the ZWI platform URL / feature branch name / microfrontend name. And now, we also needed to have the ability to work on the same feature branch in multiple microfrontends. Last but not least, we wanted something that would be super scalable. And so what we did was that the first working approach was that every time that the engineer would actually start branch typing feature branch / asterisk, the CI/CD would be triggered. The cloud, after building and testing, the code would be uploaded to a Google Storage bucket with a specific commit ID. And then the engineer or whoever would go to the front-end configuration UI and create a new feature branch, activate the newly created feature branch, and last but not least, on the microfrontend page, we would match the commit ID to this specific feature branch. In this way, we are actually able to access any feature branch running parallel on the production or staging or testing environment by using just our feature branch name. Yet again, though, we did have a problem. And what was the problem? The problem was that, let's say that the engineer would create a branch out of develop. How would they be in the position to upload it to production environment directly? So once again, we made another change, and this change was the following. In our pull requests, we create GitHub labels, actually predetermined GitHub labels, so something like feature branch _ staging or feature branch _ production, for instance, and then a new GitHub action would start. And what this GitHub action would do is automatically create all the required DB entries along with actually uploading our code in Google Storage, thus giving our engineers the ability to upload our feature branch in any environment. What do we mean with super scalability? So actually, we do have some pros and cons. So the pros are the following. We do have application resilience, and this actually is due to the fact that we actually use microfrontends. And by this, a failure to retrieve a specific version of a microfrontend actually restricts the problem to this specific microfrontend. Our main environments are intact and not polluted by any changes that want to be tested by either PMs or designers or engineers. And last but not least, and this is my favorite, there is reduced friction between our teams. And why is that? Because teams actually develop on their own pace, because we actually support any kind of feature to be uploaded whenever without actually restricting one team or the other. And my favorite is mixing and matching microfrontend versions. And actually, the fact that this is so easy to mix and match versions, we are able to test out features across multiple microfrontends very easy. Last but not least, we need actually less time to actually be organized around deployments. The only thing that is bad about this implementation is that is there actually enough money for more Google Storage buckets? And the thing is that we thought that right from the start. And the issue was that we knew that we would create a ton of Google Storage buckets to support this thing. And for this reason, we have made the following things. We have created cron jobs, schedule tasks, that what they do is essentially clean all the deleted or expired or merged feature branches. And what they do essentially is both delete all the database entities along with all the bundled JavaScript files from Google Storage. Okay, here comes the pane. So I just want to have a quick demo. You can see right here that this is the production environment. So this is our application. Essentially, each and every one of those hyperlinks right here, along with this thing right here, are microfrontends. And they are rendered right here. And this is, again, a production environment, but it also has the City.js feature branch. So, sorry, how is this thing linking? Okay, I'll just do that. So in our main production environment, when we open global search, which is this microfrontend right here, you can see that it works as expected. But when we come right here in the City.js feature branch, if we click this, we are actually able to make something completely different without polluting our production environment, which is the cool part. And last but not least, again, this is the production environment. Just give me a sec. Okay, probably more sex. Apparently the server doesn't respond. We should call our DevOps. Okay, so I would like to actually show you our tool, but we are not that lucky. Sorry for this. So, next steps. In GWI in general, we have started exploring trunk-based development because we are using Git flow. Actually, most of us, not all of us. And in case we actually implement in most of our microfrontends trunk-based development, this means it will actually need changes in our tool too, because there we have also to take into account, let's say, feature flags or whatever, right? We would also like to create a backend equivalent approach and be in a position to actually change stuff for the backend through this tool. And this is the reason that right in the start I just said that maybe it will be called deployment tool. And if we do both of those stuff, we will be in a position to actually enable A/B testing through this tool alone, which will be actually great. And the good stuff is that we will also be able to create product reports, right? And my personal goal is that I would like to have in GWI multiple full stack deployments per day, tested in a production environment without actually polluting the production environment. So that would be everything. Questions?
Any questions?
Yep. Can we get some screenshots close to that tool after you have done? Yep. Sure thing. Is there anything else?
Anything else? Okay.
Thank you.
You can find him in the conference, so he's gonna be there. Okay, next one.
Sure thing. Next one.
On Twitter or on YouTube. And thank you for sitting through a video rather than me being in person. And
but we need to go in the system preference. So yeah, so the story is that when I went to React Alicante to talk about Microfrontends, during that time Zach helped me to do my talk about SSR. And after I finished my talk, people started running on me, but then I went to Adidas was sponsoring that event, and the guys from Adidas said to me, oh, you know, we are using Microfrontends, and I thought, oh, that's a good opportunity. You want to come to London and do a talk and show us how you use Microfrontends? And this is where I brought the guys from Adidas to show us how they use Microfrontends at adidas.com. So it's a good opportunity for you to see a company in that scale and are using Microfrontends. And so this is the one talk before the end. We have one more talk from Constantinos Lemonis. And after that, there is a pub that is near to here. I don't know the name, but it's basically next to the building. What is it? Artillery Arms. So yeah, that's where we're going after.
I need help with this. Don't know what to uncheck.
So we need to go check Google Chrome, system preferences.
I'm there.
Oh, and then what? I don't know. Let's call a technician. How can we do it?
Need help with the Chrome is asking for
do this again.
Yeah. Sure.
Is it? Can we see if it's showing on the other end? Because I think this comes up anyway.
Yeah.
So just double check.
Accessibility.
Yeah, and then it should be in.
No.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got one. Let's give them a round of applause!
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the Kappa system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot of this
Okay? And now, clap your hands.
Works? Okay, cool. So we can start. Let's not lose any more time. So thanks everyone for staying this late. I didn't expect so many people to be up this late, especially interested in Microfrontends. So let's get started. About me and how I came here. So first of all, I'm from Serbia, and I have to emphasize that it's not Siberia, it's not Syria, it's Serbia. It's next to Croatia, and usually people get it at that point. Been in web development for a long time, so I still enjoy it. I still hate CSS, but that doesn't matter. And I'm doing all kind of sport, and this is probably one of the reasons why I actually joined Adidas in the first place. I've joined Adidas 5 years ago, together with my family, moved to Germany. You can find me on LinkedIn and Twitter. Okay, so let's start with the story of how we ended up using Microfrontends. So this was even before my time joining Adidas. Adidas was using a software as a service solution for e-com, and everything was really nice, except that digital business, fortunately, was growing really, really fast, and there was trouble in paradise. The SaaS platform couldn't really support this. So, of course, let's build our own e-com website. We are a big company. We can invest in that. The first thing you do, you hire a bunch of developers, and you start building something. Well, we actually started building a first website in Polymer, and you can imagine that that went completely sideways. So we started from scratch, building in React, and we managed pretty quickly to develop a first product page, and we released it in Finland, and this was a big success for us. So now we entered the age of monolith. So the new website was really successful. We built all the functionality that we had in the previous website. We rolled it out to more than 40 markets around the globe. And we are actually managing both brands, both Adidas and Reebok. Most people don't know that Reebok was part of Adidas. It's not anymore. It's a pretty big e-com website. So it has around 100 million unique visitors every month. The revenue, of course, in the meantime triples. Now we have 100 plus front-end developers, just the front-end developers. So I'm not talking about the back-end systems, nothing. So we're just talking about the front-end. And we are split in product areas, and it's approximately around 20 teams. We release to production multiple times a week, which means that we are pretty quick. We go through holiday season where we without any big issues, so no major incidents. So that's like the website was a big success. But with that comes a lot of other problems. First of all, we ended up having a monolith in a monorepo, which means that and we had like more than 80 packages that are interconnected somehow. npm install, clean npm install for us takes around 20 minutes because we have a lot of dependencies. Running a development takes more than 10 minutes. CI pipeline takes 60 minutes to complete. Regression testing, we have end-to-end tests which are written by a QA team in Java tools, which are running every night. It takes 2 hours to execute that. And then we have manual QA approval. So QAs are actually going in, reviewing the results of the test previous night. They are trying to figure out the false positives and then giving a thumbs up to release. This approximately takes 6 hours every day. But still, we managed to release a couple of times a week, which is amazing. So basically, our application at this point looks like this. Like we have a monolithic front-end application. We have an API which acts as a gateway to everything else. And we have something that we call BFF, but essentially it's just an SSR for the front end. SSR for us is super important because we are an e-com website, so SEO and performance is really crucial. And and I have to mention that at this point, this server-side rendering is completely custom because we are talking about very early days of React. So pretty much there's no Next.js, there's no context, there's no hooks, there's nothing like that, right? So we ended up having a React single-page application with the Redux, ball of mud. Everything is pretty much tightly coupled, connected to each other. Nothing can be reused outside of the repository. We have also configuration, translations, feature flags, all hard-coded inside of the repository. So whenever we need to change something, it actually requires a redeployment. Rollbacks, rollouts are all or nothing. So you have to, if you want to roll out something, you have to roll out everything. Of course, frustration all over the place. And mono repo, it just keeps growing. So it's basically we are just piling up features. Of course, nobody's deleting something which is not used anymore. So this thing just keeps growing. And at this point, we realized that we really need some special tooling. And this was like around more than 2 years ago when we started using NX for managing the monorepo. We started. We also have I have a tab open there. I don't know if audience online can see it, but we have our own private instance of NX Cloud, which we use, and it's working pretty well. We managed to do a lot of caching and distributed caching benefits, but still we managed to get the builds from 60 minutes to 45 minutes approximately, right? So that's a good step forward, but it's not what we want. So okay, so now we are thinking that this is not going to scale a lot, so we have to think we have to find a smarter solution. So this is why we ended up establishing this program, which we called Agile Experience Layer. And this is the first lesson learned here. If you want to get something, a buy-in in an enterprise organization, you just call it Agile something, and it will be sold, right? So nobody argues against that. So. So here, and this was our mission. So we wanted to make quick and fast new .com experiences. We wanted to keep consistent look and feel across the website. We wanted to provide a great developer experience while building the website. So how do we do this? Of course, microfrontends, right? So this was our target architecture, right? So first of all, we wanted to, because the site, so we have really a lot of developers, right? And these developers are separated in different departments even, right? So it's not even anymore like the front-end development kind of department for .com. We have more departments than that. And we have side projects coming from many different sides. For example, like a business unit comes in and says, I want some completely custom campaign which doesn't have anything to do with the rest of the website. So instead of just pushing these things to one application, we just said, okay, let's first slice the elephant vertically, and let's have multiple applications, which you see here on the top, which are first separated per product area. So we have upper funnel, which hosts the landing pages and the product pages. Then we have checkout, which is serving the lower funnel of the website, the payments, the creation of the order. And we have account that deals with everything around the user. And we have these side projects, which are the blog, the help pages, etc. And of course, all of these applications and pages are sharing a lot of functionality. So on the bottom, you see some of the micro front ends that we are building. So header and footer are obviously the first thing that we are going to build. Yeah, so I'll talk about this in a second. Yeah, you can see that there is a lot of them, and the number is growing, right? So in here, I have to say a couple of things. So first of all, like we set some hard requirements when we started building this. So first of all, we cannot stop the world. We cannot stop development of the old website and just do this instead. We had to develop stuff in parallel. Second thing is that SSR for us is like crucial requirement. So it cannot work with SSR, without SSR. And the third requirement, which was very interesting, was that we should be able to deploy our micro frontend on a WordPress website, right? Because we actually had scenarios like this. Basically, we had agencies which were building some blogs, some other blogs, not these blogs, which are deployed using WordPress. So if we wanted, we could deploy. We needed to deploy a micro frontend even on that website, right? So this, of course, complicates things a lot, and we are talking about a lot of things which exist today are in very early stage of development when we started this, or didn't even exist, right? So this is why you will see something which I won't mention, unfortunately, Model Federation. So, but bear with me. I'll try to explain how we do things. So essentially, like this is. Let's say a high-level flow, how we serve our site. So first of all, on the left side you see the user. That's easy to spot. In the middle you see the application, which is basically just an XJS application. And on the right side you have the micro frontend. The micro frontend in our case consists of three main things. The CSS part, the JavaScript part, and the render endpoint, which actually produces the HTML. So Index.js, if you use single SPA, you might notice the similar interface, and this was the inspiration actually. So we have similar interfaces the single SPA has. We have mount, unmount, and update functions, which are called by the host application. And the render endpoint is basically an endpoint which you can hit with the different query strings, which acts as an input data, and then it responds with some HTML and some metadata, right? So application does rendering in two passes. So the first pass is basically you just render a page with some placeholders for the micro frontends. And then at the next stage, we actually inject, we call the render endpoint and we inject the HTML. So basically, we do server-side inclusion in our own custom way. And when we ship the page to the client, we ship the page with also resources all included alongside with the HTML. And we have our own custom way of making sure that the React hydration works as expected. Okay, so let's see, like this is all backwards. So I will first show how we use the microfrontends in the application, and then I'll go a bit inside how we are actually creating microfrontends. So the first thing here is that you can see that this is just plain React, right? So there's nothing here around some magical stuff that the developers needs to know. They are basically using this custom component, which is called microfrontend client, which has some parameters where to load the microfrontend from, and it also has this flag that says SSR enabled. We support both client-side, server-side rendering. You can turn off server-side rendering if you don't want that, and you just the client is responsible for loading the thing from the CDN in this case. So, and also you see that here in the middle, we have all the child components are rendered as a loader, meaning that this thing will be shown until the microfrontend actually loads and renders on the client side. In this case, this is just a spinner. Okay, how do we create microfrontends? We created a framework for that, which we call Sole. Of course, sole of the shoe makes sense, right? And Sole itself doesn't only have like seeds for creating the microfrontend itself. It's much more than that. It actually offers us, because we are an enterprise company, everything self-hosted. There is pretty much no Netlify-like experience or Veracel-like experience. We have to build these things ourselves, right? So for example, creating a repository, you run a generator, which is like this long command here. Once you get you will get a Bitbucket repo in our case, and you will get Jenkins pipelines created for you, right? So this will be automated. Then if you want to create a microfrontend, you can run a seed of the project with a command like this, and here you can see that the type is actually microfrontend with SSR. Once you actually run the seed, you will get something like here on the left, where you have like the folder for your client code, the code for the server, and also everything else generated, like the pipelines code, the Docker files, all these things are already generated. If you take a look, for example, at the Jenkins file, this is what you will see. Like basically, we are using some global library which handles all the CI and CD stuff for you. How do you create a microfrontend? Well, there's nothing really interesting here except that the developer only sees React, right? They don't know they don't care about how we load the microfrontend. They just use some Sole framework libraries to get some state or to handle for the error boundary or some base components. And here in this particular case, we have something that we call host info, which is essentially providing data about the environment and the brand and the locale where your microfrontend is running in, right? So the developer is only working in React. They don't know about the specifics of the framework, right? Once you are happy with what you did, you can just commit your code and push your code. By default, we have like a certain workflow. When you push code to main, you will get an environment deployed you will get your code deployed in the development environment. And when you're ready to deploy to production, you can use Sole, deploy, and choose your environment. So okay, so we made all of this, but is there any benefit, right? So first of all, we now have since we don't have a single repo or mono repo, we have repo per domain. and which makes things a lot easier to just for people to get onboarded. Like if you check out code and there is a ton of code inside, you need a map to navigate around. So if you have smaller repos, things get to be easier to understand for especially for the new joiners. Then the second thing is the NPM is a problem. For code, smaller dependencies, it takes like around 2 minutes to install some random micro frontend. NPM dev takes like a couple of seconds to do because the code is very, very small. And here I have to mention that we decided to use Vite for the new tooling. Previously we used Webpack. So this also benefits us for this in terms of speed here. CI pipeline now takes 10 minutes, and the thing is that we are even running more things in the pipeline. For example, we don't have regression testing anymore as a separate step. The regression testing is part of the main pipeline, and then there is no more QA approvals. We do continuous deployments now. So we manage now to do multiple deployments per day. Instead of a couple per week. And of course, the thing that I didn't mention is that now we also extracted the feature flags and translations and configs as a separate service. So now you can just make a change without requiring an additional deployment. Key learnings for us. So first of all, like for mid-size or small-size project, microfrontends architecture would do more harm than good. Second, SSR makes things a lot more complicated. You have to think about executing the similar code or same code in 2 different environments. This is complicated to do, but Zach will talk about that, I guess. Also, one of the things that we had to deal with was caching and versioning. So we talked about that as well. This was also kind of a hard problem for us to solve. Second thing, like for us, it was, I should make a note here that for us, it makes sense to be agnostic because we know that what we do right now is not going to be relevant in the future. And we did the migration from one code base to another, and it takes years for us to do that, right? So if we need to migrate to a different tool, to a different framework, to a different whatever, we need to be able to do so without actually rebuilding everything, right? So this is for us really, really key, right? And we will probably, like in this transition period, we will suffer in a bit, like in terms of performance, where we double load things or we don't do something in an optimal way, but we still can actually do this migration, which is for us key. So we have the SOL framework to keep everybody aligned, but this is key, right? If you don't have like a core team, like a platform team, however you want to call it, and like that provides guidelines for everybody to use, you have complete chaos. Like and the teams really have a lot of autonomy, but there should be at least a framework which gives you an easy way to do the right thing, right? So that's the important stuff. I mentioned SOL and what it does in terms of automation, creation of the CI pipelines and everything. But also we do a lot of other automation. For example, we have Renovate to manage dependencies between repositories. So these things become very easy. We have automation to manage deployments, to make changes to the CDN. In our case, it's Akamai. This is also something really important, etc. Right? So, and we are investing in this more and more. Continuous improvement, of course, we know that the things that we are doing today will not be effective tomorrow. So we know that we are going to change things as we go. For example, things like sharing state or how we do versioning, and these things will change. And one of the things which I think it was mentioned before, for example, how do you get like a overview of everything that's running out there? That's something that we are currently busy with, right? So with that, I would like to say thank you to Aris and CityJS for inviting me and for organizing all of this. And thank you all for listening.
Any questions?
This is what teams do. They build this kind of environment, and then we can also use a lighthouse to run certain tests on top of this, right? So these are the things that we are doing, and of course, all of these things are still in development, right? It's not something that we just teams are adopting this as they go, right? So some teams are more mature, some teams are not so mature, but we are working with all of them to adopt these practices.
Any other questions? Okay.
Yeah.
How many teams do you have for the platform? One and only, or?
It's right now it's a hard question. So first, like I forgot to mention that part. So we are .com of Adidas. So other teams in Adidas have module federation for a different completely tool. They have single SPA for some admin tools. They have custom implementation of microfrontends in some other tool, right? So Adidas is really, really big, right? So when you say platform, I'm just talking about the .com part, like the website of the shopping part. So there we have one tool which I lead, which is like the web runtime team, we call it so, which is dealing with this whole framework development. And we have another team which is dealing with building these tools which are used across other teams, like translations, configurations, feature flags, automation of Akamai, and these things. So in total, it's 2 teams, and in terms of people, it's around 10 people that are handling all of this.
Great. Okay, so you're going to see him again in the conference on Friday, and a lot of other people. Zach has a question.
Yeah.
So just out of curiosity, in the beginning you were saying that you started off with SaaS, and the scaling eventually took that out of the running.
Yeah.
Are you able to say what SaaS you were using to run your storefront before you had to go?
No, I mean, we can talk about that later.
Awesome. Thanks. A big clap. Thank you. Okay. 2 or 3 minutes if you want to have a break, and then we put the next speaker. Yeah, okay.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes, we've got a person, we got a winner. Let's give them a round of applause.
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the kappa system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who...
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we've got one. Let's give them a round of applause.
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the compact system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who...
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we've got one. Let's give them a round of applause.
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the compact system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who...
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we've got one. Let's give them a round of applause.
with some accent. But now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English. Okay. And now we can continue to
the combat system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Hello everyone. Last talk of the day. It was a full-on micro front end. So the last one, we saved the best, the last for the best, isn't it? And this is the pragmatic approach to micro front end. So you heard a lot. Now you need to see what is the pragmatic approach.
Thank you very much. Thank you very much, Aris. Hello, everyone. Hope you're not that sleepy right now. You're not full of food, and you're actually with me. Are you with me? Yeah? Yeah? Okay, that's great. So this is going to be a talk about the pragmatic approach to micro frontends. As you can say, micro frontends have actually gained a great traction the last few years. This is basically for a very good reason. This is because they're able to break down your organization's monolith down to your manageable and more small parts that you're actually able to deliver, develop independently, you're able to deploy independently. And yeah, basically this is the adoption to micro frontends is not easy. And you basically need to decide that on many different factors. These factors can actually be, if you have like a very complex UI, that could be a good option for you to move to micro frontends in a way that this is going to be split down to more manageable parts. If you have like a very, very big application that is going bigger and bigger, this is also going to be a good option for you. And also, if you have a very big team. So, for example, you can imagine that a team of 20 engineers that might be working on a single repository in a monolith, they might be more easy to work compared to a team of 200 engineers. And yeah, as long as people are getting more and more and you're increasing the team's capacity, this is getting harder and harder. And yeah, basically with that, I'm Konstantinos or Kostas. This is my name actually I write here in the label because I wasn't able actually to write the whole long Greek name. I've been raised in Greece and I'm actually living and working in London. I have been building micro frontends since 2019, thanks to Luca Mesarilla. I've been working at DAZN, and currently I've been actually working at BitDev, where we're actually building the future of micro frontends. And here is my Twitter handle, if you have any questions or you want to reach me out. So what this talk is going to be about? This is going to be about a discussion for the adoption to micro frontends. When is it a good time to adopt to micro frontends? What is a pragmatic approach and how does it look like? And finally, a demo. Hope we have the time to do that. Before we jump on, how many of you do you want to migrate to micro frontends? Yeah? Yeah. Okay. And how many of you are you already using micro frontends? Okay, that's great. So basically, based on the recent research from the state of frontend, more and more companies are actually adopting micro frontends. You can see that there are like, from this research, 25% almost have been using micro frontends. And based on the Luca Mazzarella was actually mentioning, this is getting better and better because you actually have the chance, more companies and organizations to provide some more feedback and to realize what are the good patterns, the bad patterns of this approach, and also get more like get this architecture and grow. So speaking of adoption, adopting microfrontends is not an easy job. It's not a mundane work. It can take like time and can take effort, and this depends on how much time and effort your team has to focus on. If you have a platform team, if you don't have a platform team, or if you have like only features team, depends on the business initiatives, everything like that. But in order to adopt to microfrontends, you basically need to make some decisions. And out of these decisions, you basically also need to think of ahead what is going to happen in the future. So taking that into account, future is really hard to actually forecast. What is going to be happening in the future in your platform? What is going to be look like? So this makes your decisions even harder. So what I say is basically that you better take a decision at a time. This is going to be a step-by-step migration process, and it's better actually to make some decisions and take some time to migrate to microfrontends in a way that you can actually focus on the facts that you know at the moment. You know what is happening on, you know the requirements, you know the needs that you have in your company, in the business, but you don't know what the future will actually come up with in your engineering platform. So you better actually embrace iteration, and with that you better like get a step-by-step migration process. You can actually review that, take that one step at a time, and be able to proceed in the future with that approach. But you might be asking when might be a good time for you to move to microfrontends. And this is basically depends on a few different factors. Some of them are you might have a complex application, UI application that have different parts, moving parts that you're not able to scale in the right way. So this is going to be a chance for you to start using microfrontends and to break down this complex UI to more manageable parts. You might have a team that is growing as well, and you might have from a single team that was responsible for this microfrontend, you might be moving to a multiple team structure that will be responsible for this microfrontend. On the other hand, you might also need independent scaling, which means that you want to be able to independently release to production different versions of microfrontends, which is also a really important factor so as to give flexibility into the different teams inside your company and be able to work autonomously and independently on these applications, be able to deploy to production, and don't need to care about the rest of the application. One more reason for that, when it is a good time for you to move to microfrontends, is basically when the monolith grows that big that is really hard to maintain. I mean, we have started like projects that seemed simple at the first, and they started growing and growing and growing. This monolith went that big that you weren't able to maintain anymore, and it was like a greater effort for you to take the time and make a release. So release can be really painful in that case. So you cannot actually continue maintaining this monolith. And the way that you can do that, you can basically migrate to microfrontends in a pragmatic way. And what this looks like, let's first actually try and see what the pragmatism is meaning. So pragmatism is basically an approach that is practical, realistic, and focused on achieving specific goals or outcomes. Considers the context and constraints of a situation and seeks to find the most efficient and effective solution given those circumstances. What that means for microfrontends, basically we can start with the Conway's law, which what does it say is basically you should start looking into your organization. Instead of actually looking on the code base and how your monolith is structured and how you can actually split and create teams out of your monolith, you could basically better look into your organization and find out what are the communication patterns, what are the communication structures, and based on these structures, try to create those software teams, those structures that will create the different teams in your software that will be responsible for different microfrontends. And to continue that, basically what you need to do is you would need to analyze your current implementation, your current monolith, to see what are the different components, what are the different parts that you could split down. Define some boundaries around these microfrontends based on the user experience, based on the requirements, and based on how the business is actually scaling up, how the business is actually structured. Then based on that, you can actually start planning about the refactoring. You can create a timeline, you can allocate resources, and you can finally create some deliverables out of it. You need to prioritize in a way that it won't break the application of your organization. So, for example, you can start with a microfrontend that is basically a great value for the company, but it's really easy to migrate to. And as a next step, you will need to start to develop this microfrontend, create the specific API contracts. So, for example, you can actually create the interfaces, how these microfrontends will actually talk to each other, how they're actually sharing information, how the host will actually communicate with your microfrontend, and start integrating that. Start integrating that in your host application. And this is a way you will be able also to roll back in a way that everything that you develop and everything that you deploy in production can actually be reversible. And of course, you shouldn't forget about monitoring and maintaining your application in production. So you will need some good error tracking, some good error logging, and everything about that. And the benefits about being pragmatic is basically you are able to make a gradual integration, so you can get step by step. And this actually brings you with reduced risk, so you're not actually risking your whole application breaking up in the production environment. The teams are able to focus on this specific microfrontend in order to be able to migrate to. And you're able to be scalable in a way that your microfrontend can actually deploy independently. In that way, your teams are flexible because they can actually create their own toolings. They can decide how they're actually going to be their flow in order to be able to release to production, and how often they want to do that. And through this process, you actually need to iterate and innovate through this continuous and fast development delivery, basically. To move on, we basically have a demo today, and this demo I want to have like a specific use case. So, for example, we are developing a web application for our great streaming platform, which is called Video Plus. Anything that reminds you something else and doesn't mean anything. So basically, you have like this streaming service, and you have some new requirements from your customer. So you have like this monolithic application, and the business is basically deciding to create a new team, a business team and a product team that is going to be focusing on user engagement. And they decide that they're going to be creating these teams, and they want a development team that is going to be focusing only in that particular part of the business initiative, which is going to be the user engagement. So what are you gonna do now? So they believe that they're going to be feeding into this banner, as you can see over here, this slider. They're going to be feeding more information, like for example, movie details or some more information like titles and everything like that. And they also want to experiment with a video preview. So the team is basically busy developing other features inside your company, but you want to create a dedicated team in order to be able to deliver this initiative. So you're going to start with, and this is actually how we're going to start with our demo. If I go back to my YouTube, there it is. Okay. Can you see my editor? Yeah, is it looking good? Okay, amazing. So what we have here, we basically have a monolith. I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got one. Let's give them a round of applause.
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the combat system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot from this.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got one. Let's give them a round of applause.
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the combat system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot from this.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who...
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got a winner, let's give them a round of applause!
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the combat system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot of this.
Okay? And now, clap your hands.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who...
Number 9 of 20, whose phone's gonna ring? Oh, yes! We've got a person, we got a winner, let's give them a round of applause!
With some accent, but now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English, okay? And now we can continue to
the combat system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot of this.
Okay? And now, clap your hands.
At birthday, and you can do it there. So if you want, you can come there, and you can sit there. Okay? Thank you, everyone. Sorry, Έλα αύριο στο birthday και το κάνουμε εκεί. Από τις 10 μέχρι τις 4. Στο τέλος έλα. Όχι, έλα γύρω στις 3 η ώρα περίπου. Θα σου στείλω μήνυμα. Εντάξει. Είναι στη Russell Square.
Είναι κοντά στο...